Hi everyone, welcome to this new course. In this course, I'll first teach you how to make a gamified portfolio website using JavaScript and the Kaplay library, which is a library for making games in JavaScript that is very easy to pick up. And then we will build a second one in JavaScript and Kaplay, and also adding on top React. The prerequisites for this course is just JavaScript, and that's it. You should know what JavaScript is and maybe Node as well, what Node.js is. Otherwise, I will be teaching you in this course how Kaplay works and React also. So if you want to see more content like this in the future, feel free to subscribe so you won't miss out. I just want to say that these courses were once published on my channel previously, but I have reworked them in the audio department, so I have improved the audio quality a lot. So it's the definitive way to watch these tutorials. One other thing I would like to mention is that in the first part of this tutorial, I was using a library called Kaboom. Well, Kaboom is just Kaplay. It has the Kaboom library has been rebranded and forked. So, but essentially, Kaboom and Kaplay, it's the same thing. Kaplay has more advanced features, but the first part of this tutorial is still relevant, and you will be able to easily move on to Kaplay in the second part, where I will teach you Kaplay specifically with the second project. As for deployment, I have left in the description a link that you can read to learn how to deploy the projects on GitHub pages. Thanks for watching, and I hope I'll see you in another video. Bye. Hi everyone, welcome to this new video. Today we will be building a 2D portfolio project. So it's a 2D developer portfolio, but as a 2D game. And without waiting much further, let's jump right into it. So this is what we're going to build. You can move around a house, and then as you approach objects, you can have a text box that tells you a bit more about yourself. Here I've selected some text. For example, here there's my CS degree. This is my CS degree. I hanged it on the wall because I'm proud of it. And then if you move around, you go here. You have a place to have your resume. You can click. If you click on that, it will open a link with your resume hosted here. For example, this is just a template. So this is the idea behind the project. Here you have a bit of text. So it's an original way of making a software developer portfolio. I've seen a couple where it was in 3D, but nobody seems to have made in 2D. Actually, there were some, so I thought I would just teach you how to do it. What's interesting here is that we're going to build this project with JavaScript and the Kaboom.js library. So Kaboom.js is a library for making games in JavaScript. It's very easy and intuitive. But also for all that is the text here, the text box, the text here as well, this is all HTML and CSS. Here, because the reason is that for this project, everything should be interactable with the mouse or the touch screen. So if I open the DevTools and go to the mobile view, and then here, you should be able to move around, and the text therefore should be responsive. So here, example, you have a text, and that's it. You can close. So for this to be achievable, for the game to work on all aspect ratios, it was important for me to make the UI portion of this project in HTML and CSS. So let's jump right into the project, but before we do that, I just want to mention a few things. So if you're interested in having written tutorials, you can go to my Substack. The link will be in the description below, where you can have written content that explains specific concepts. So on YouTube, I make full-length project tutorials, and sometimes you just want to know how to do one specific thing. So the Substack here, my newsletter, is for that. So here, for example, for this project, it's going to be relevant to know how to implement 2D top-down controls for a mobile web game. So here we go. You have videos here that just showcase the results. Another thing I want to mention is just to showcase my Buy Me a Coffee page. So if you want to support the channel, you can buy the support with $5 a month and with this tier, and you get access to this tutorial you're currently watching and all the future tutorials in advance, so early access. You also get early access to the to the source code and some progress updates as I do them. So if you're interested in supporting the channel so I can focus more on making tutorials, feel free to contribute here. You can also just leave a normal tip if you want. All right, so let's jump right into the project. So I'm going to use for this project VS Code. It's the editor I use mostly for everything. And here we're gonna need a few things. So let's start our project. So I assume that you know how to use VS Code at the basic level. So you have it installed on your computer. You also have it, you have Node.js installed also, which is going to be important for this tutorial because we're going to use Vite. Vite is a bundler that allows you to write your JavaScript in a more convenient way. So we could use script tags as we did in a lot of the previous tutorials, but with Vite you get you can install your dependencies by typing in npm install, and it's just more convenient in a certain sense. And you will also get auto completion and snippets, code snippets from the Kaboom.js library that tells you this is this feature, what it does, which is something you don't get if you just use a script tag. But feel free to follow using only a script tag if you want. The setup sections of previous tutorials are going to teach you how. So yeah, I'm just going in this specific tutorial, I'm not going to spend a lot of time on this. So the first thing we're going to do is to type npm create vite at latest, and then dot, because we want to create the project within the same folder we're currently here in. So here it's 2D portfolio. So I hit enter, and then we should have something appear. Need to install the following package. Yep. And then here it's going to ask you to select the framework. We're going to go with vanilla JavaScript. And it's going to add a bunch of stuff. So for now, just do npm install Kaboom. So it's going to install the Kaboom.js library. Whoops, I hit the wrong thing, but hit enter. Is it going to work? Okay, all right. So it's going to install the project, and then in your package.json, you can see all your dependencies. So here we have Kaboom. All right, now the rest of the project, we're going to need to set a few things up. So the first thing we're going to set up is I'm going to remove a lot of the boilerplate you see here. I'm going to remove main.js. I'm going to remove counter.js. I'm also going to remove this. And within Vite SVG, I think it's not needed as well. So this, remove, and also the style.css, we're not going to need it for this project. So delete. Okay, now once we have this, let's create a few folders you're going to need. The source folder, src. This is where we're going to write our code, our JavaScript code. We're also going to need the public folder. I deleted it by accident. I wanted to just delete what was in the public folder. And we're going to create at the root of the project a vite config.js file. This is going to be useful for a specific reason. We want to be able to export. So the way a bundler works, it compiles your JavaScript. So the Node.js JavaScript that you write and the JavaScript that runs in the browser is not necessarily this exact same thing. So this bundler basically transpile or compiles your JavaScript to a JavaScript version, or it's a bit hard to explain, to a version of JavaScript, not a version, to JavaScript that can run in the browser as is. So, yeah. Now, the reason for this is that a lot of features were not supported in the past in the browser version of JavaScript, while in Node.js you could have things like convenient things like using import statements. But now import statements are actually available in JavaScript in the browser. So that's how I've been doing the various projects you've seen on the channel, if you're familiar in the past tutorials. So in the vite.config.js, we need to specify certain things. So not just want to clarify again that not only does a bundler transpile your code, your JavaScript code, so it can run in the browser, it also do optimizations, minification, so that your code is really compact and takes the least amount of space. All right, so here I'm gonna do export default and then define config. This is coming from Vite, so it's gonna import it from Vite here. And then within, we're going to have to specify the base. So the base here, when we run the npm run build command, which is used to do the transpiling and gives us the actual code, that is going to be used, that you actually put on your server or on itch.io to have your website up. We need this base thing. Otherwise, it's not going to be able to find the assets, for example, the sprites we use with Kaboom.js. The second thing we need to specify is the build. And here, the minification, we're going to use something called Cursor instead of the default ES build. So the reason for this is due to Kaboom. There is a bug with the way Kaboom is made, that if you just use the default, it's going to give you code that doesn't work. The actual output will no longer work. So that's why we need to install this alternative called Cursor, which is going to make our code Cursor, so smaller, minified. So once this is, I should have installed it as a dependency. So npm -d for dependency, install Cursor. I think that's the command, or if it's not that, it's going to be the reverse. All right. Now, if I look at the package.json, you can see that as a dev dependency, we have added Cursor. Okay, we have everything we need. So now I'm going to create a main.js file. And in the index.html, we're going to have to do a couple of things. So I'm just going to remove that. So the first thing we need is to create a style tag within the body. This is where we're going to write our CSS. Now, you could have decided to use an external CSS file, but because this project is not really CSS heavy, it isn't really that necessary. The second thing we need to modify is here, the script tag that imports the main.js file. We need to actually modify the path to be source, like that, because we have created the source folder in which is our main.js file. Okay, now in the div, we actually can work this out later, but actually, never mind. Here, we're going to create our canvas that we're going to give the control of it to Kaboom. So I'm going to call it game. The ID is going to be game. And here, we're going to have a div that is going to have the ID of UI. I'm not sure if I'm going to use this later on. I might just remove this ID, which just is going to contain everything that is the UI. So the text box and text. All right. Now that we have this in our source folder, I'm going to create a file. This file is going to be called Kaboom context.js, so CTX to abbreviate it. And this is where we're going to set up Kaboom. So I'm going to use import Kaboom from Kaboom. This is possible because we have installed Kaboom.js. And you can see that there is a difference in the way native JavaScript that works in the browser deals with imports and how this Node.js version of JavaScript works. So if we were to use the native JavaScript in the browser with modules, you have to add the .js for the file extension you want to import. But this is not needed when you're using a tool like Vite. Okay, so here I'm going to create our canvas, our Kaboom context, which is going to be unique. And through that object, this K, we're going to call all the functions we need. So we're going to pass this around in our project. I think this allows us to have cleaner code as the project grows, instead of having to importing Kaboom globally, where all functions can be called directly from anywhere. So this is a pattern I recommend that you use for your Kaboom.js projects. So when you create the Kaboom context, you need to pass a few params. Actually, you don't need to pass any params by default, but if we want to achieve the thing I said about not making it global, you have to pass in the global property and set it to false. Then here, this is going to be relevant for the fact that we want our project to work on mobile as well. So we want to have the touch to mouse property, which again is from Kaboom, and set it to true. It's going to translate all touch events on the phone to click events so that you can basically write your code with the mouse in mind, but it's going to work just as well with mobile. And then finally, we can have the canvas property where we're just going to give to Kaboom the canvas element. And the way we're going to do that is by using document get element by ID. And here we give it the game ID. If you remember in index.html, we gave to this canvas the ID of game. So we're just telling Kaboom here, take the element, take control of it, and do whatever you want, whatever you need. Okay, so now that we have this, everything is fine. And in main.js, we can start writing our code, but before doing any of that, let's create all the other files we're going to need. So constant.js, it's going to contain, as the name suggests, constants, which is also going to contain the specific dialogues and the scaling constants, etc. And then finally, we need the utils file, which is going to contain a few functions that just to make our code look nicer. So in this project, it should not take too long compared to my previous projects. So yeah, if you could have made everything in just main.js if you wanted. All right, so now in the public folder is actually where we're gonna store our assets. What I need you to store is the font monogram.ttf. You're gonna find this in the link in the description of this video. If you're an early member of if you're watching this in early access, you should have also a link. I'm either going to drop it in the post or in the actual video, so you should it should be obvious where to get it. And now we're also going to need the sprite sheet that we're going to use for this project. This is the sprite sheet. The link is in the description as with the text. And then finally, we're gonna use an external program called Tiled to draw our maps. But for now, let's just keep those two things. And then in main.js, let's actually start writing our code. So I'm gonna import the context from Kaboom. And here the first thing we're gonna do is use the load sprite function. It's a function that allows us to load an image as a sprite. And then we can specify a bunch of frames. So here I'm giving it the name of sprite sheet. And the second param should be the path where to find it. And it's going to be sprite sheet.png. Now, the reason this is just ./sprite.png, despite the fact that it's in the public folder, so normally you would think that it would be / and then public/sprite sheet. But the way Vite works is that you can assume that everything that is in the public folder can be directly accessed like that. So this is something specific to Vite. Now, the third param is going to contain a bunch of properties that tells Kaboom how to slice the image into various frames. The first two properties is the slice x, so how many frames are on the x-axis. Here, 39. How did I come up with this number? I just counted the number of frames, the number of frames here. You could do that with tiled as well to give you the number. And then this is something you should know. So for example, each of those is each frame in this image is a 16 by 16 tile. And that means you can know roughly like if you take the length of the image, which is here 624, and then you divide it by 16, you're going to get the number of tiles or frames that are going to be on the x-axis. So you can manually calculate it with math. All right, slice y is going to, again, describe the number of frames that are in the y-axis. The same logic can be used to calculate it. So knowing that every frame is 16 by 16, this is the way this sprite sheet is designed. You can just take look at the height of the image in the properties, or here in VS Code on the bottom right corner, and you divide that number by 16 and you get the number of frames. All right, now here comes an interesting part. It's called the anims property, and here it's where you hook up specific names to specific animations. So here, the idle down animation for our character is just going to be one frame, and it's going to be frame number 536. Now, how did I discover this? It's by using a program called Tiled. This program is called Tiled, and I think it's actually a good time to create our maps, basically create our map. And while setting things up, we're gonna see how I figured it out. But just to be quick, you click here on the frame you want, and then you get the ID, so the number of that frame. Now, let's assume you don't have any knowledge of Tiled. So install Tiled by using the link in the description. Once you have it, you should have this editor. Let's assume you have a new project, so I'm just going to create a new map. And then let's, I don't remember the dimensions I've used, but don't touch anything here except specify the width as 16 pixel, the height as 16 pixel as well. As for the map size, make it fixed, and then take these numbers by default. All right, we have the map here. Now, another thing you can do, because if you're using Tiled on a wide monitor, for example, things might not be clear. So you go to Edit, Preferences, and then in Interface, actually it's in Theme, you check Use Custom Interface Font, and then you can select a specific font and then increase the font size. This is useful for you to be able to clearly read things. Once you have this, in the map, you can go to, I think it was map properties, actually maybe not, a world, okay, in view, snapping, no snapping for this project. If you clicked on snapping, snap to grid, it's going to make sure that everything fits into a grid pattern. I think for tiles, it's in grid pattern regardless. But if for the collisions box we're going to draw, we want to find more fine-grained controls. So that's why I deactivated it for this project. Okay, now add a new tile set to the right. Okay, now browse where you've put the sprite sheet in your project and link it here. So this is it. So for the path should be here. And then this is specific to me. So for you, if it depends on where you put it, the actual project. And then just don't touch anything. The tile width and tile height should be 16 by 16 pixels. And then hit OK. And now you have the sprite sheet. So a good thing right now would be to save the map. So go to the file, save as, and then name it map.json and put it in the public folder of your project. All right, so you can see that I've named it map.json. This is the name I want you to use. And it's going to basically create a JSON file in your public folder. So if I minimize this and go here, you can see that we have map.json. This is important because this is how we're going to know where to draw the hitboxes and where to draw certain things. So if I go back to tiled, for now, we only care about knowing how I figured out the 936. So here it is. 936 comes from the end. As you click on the various other tiles, you can see the various numbers. This is how you can know which frame is which. Okay, now I'm not gonna copy paste. I'm not gonna write the code for this. All the animations we're gonna use by hand. It's gonna take too much time, so I'm just going to copy and paste it here. So here we have the idle down animation, which is just one frame, with the walk down animation. So how do you specify animations with more than one frame in Kaboom.js? You use this an object. You pass in an object with the from property, which is the starting frame, the to property, which is the finishing frame, and whatever or not you want to loop. This is not mandatory because by default looping is false, but we want the animation to loop always, and we decide when to stop it and when you cancel it. And then the speed is the frame rate. So here 8 frames per second for this. So we have 4 frames in this animation. So a speed of 8 is what looked good. So if I go back to tiled again, you can see 1, 2, 3, and 4. This is how you know. This is how I knew it was 4 animations, 4 frames. Sorry. And then here it's the same thing, but with the various different directions. So here for the sideways, we only need to have one of them. I think we're using the right one by default. Yep. And we're just gonna flip it over when we need to make the character look left. All right, so now that this is done, I think we can just start drawing the map. So I'm gonna open tiled again. Now here, I really want to have the same thing, but yeah, this is always a difficult part of the project where I just want to copy the map layout instead of doing it manually. But just to teach you, so what I'm going to do is I'm going to teach you how to make a watered down, like very simple version of this map, and then you just take my map.json file here and you use it. So the map.json file that I used in the project, in the actual project, is going to be in the description. And this is just a tutorial version that you can just swap out. So this is just to teach you how to use tiled. So once this is done, I'm just gonna use the actual real map.json instead of writing the code as if. Anyway, all right, you get the point. So just to teach you the way you draw things. So let's have, okay, the way layers works. So I'm just gonna, this is just a small crash course on tiled, how to draw maps. And yeah, so by default, you have things called tile layers. So tile layers are layers that contain tiles that you can draw. There's another type of layer called the object layer, which contains collision boxes or spawn points, which is basically needed to know where to set where the collisions are, etc. So let's say we have this first layer called ground. So you decide on the name, and depending on the name, the resultant JSON file that you save is going to contain those names, so you can know which layer is which. So here, let's say I draw the ground like that. So I drew a couple of tiles. Everything looks great. Now, if you want, you click on this button to add a new layer. Let's say I add another layer, and I'm just going to call it plants or props. And then I can draw on top of it like that. And that's basically it. That's how you draw a map in in tiled. Now, when you want to add collisions, what you do is you create an object layer, call it, for example, boundaries. And then here at the top, you can have access to those shapes. And then here, for example, a square. Let's say I want the player not to be able to escape outside this little square. So I can do here and then draw a grid like that. Here it's often better to have the snapping set to snap to grid. If I do that, it's going to be very easy to make perfect, pixel perfect collisions, boundaries. But now if I go back to here, snapping and no snapping, and I want to draw, for example, for this tree, this specific shape, and then this specific shape. So you have more fine-grained control. And now this doesn't do anything on its own. It's just for you to know that, hey, there's this layer called boundaries, and it's going to be an object layer, and this is what. And when you're using an object layer, each object you create in that layer is going to have the x, y coordinates and the width and its height, so you can know what to draw, where to draw the hitboxes when you're working in Kaboom or in JavaScript. You don't have to use Kaboom to use tile, by the way. Now the other thing I want to talk about, it doesn't have to be a separate layer, but let's say we create a separate layer, and I'm gonna call it spawn point. Not spawn point. What is this name? Anyway, spawn point. And then here you can use this pin, and when you place it, it's gonna basically create a coordinate that you can use as a way to know where to spawn the player, for example, or NPCs or mobs, etc. So this is how tiled works. So once you're ready with this, you just save it. Now another thing I want to showcase is that this is not enough. What we want, so this is something specific to Kaboom. So usually by default, it's better to draw normally in JavaScript or in any like programming language. It's better, like it should be more efficient to draw the frames tile by tile instead of like having an image that contains all the tiles. But in Kaboom.js, it's different in the sense that it is more performant and easier to maintain if you just go to your tiled editor and do export as an image. So what this is going to do, it's going to combine all of your tiles here as a single image. So if and only include visible layers. So before doing anything like that, you need to make the spawn point and the object, the boundaries layer invisible. Otherwise, it's going to appear in your project. And then you save. And then you go to File, Export as Image. And then you export, only include the visible layer. You don't touch any of those things. And then export. Now here, if I go in my code editor, you're going to understand. So map, you see, all the image is baked as a single one. So here we go. Now this would be inefficient or less efficient in other libraries, etc. But with Kaboom, because when you create new tiles, you create new game objects, it can be, because game objects in Kaboom.js, you create things called game objects, which are usually your player, your tiles, anything. And when you do that, it is performance intensive because every game object has a few components. Those components do some stuff, etc. So a way to get around that, not have to do this or pay the performance tax that comes with it, there are many ways you can adopt. The simplest one is just to bake your image, take your tiles and just combine them into a single PNG and just draw that as is. Now the tiled export is still useful because in tiled you're going to have this map.json, and then for layers that aren't tiles, you get the object layer and the position of the hitboxes, which is still valuable information you're going to need to draw the hitboxes in your map. Otherwise, the other option would be to use the onDraw function in Kaboom.js to draw the tiles specifically without having to create a new game object. But it's just more complicated it's a better alternative, but it's just more complicated. And for this project, I just opted with just taking a single image, using a single image. Yeah. Okay. I think I've taught you everything important related to how to draw things in Kaboom, and tiled and etc. Now, what we're gonna do is I'm gonna swap the files here. I have the map.json, map.png with the actual maps. So you can see, actually, one thing I realize now is, never mind, you still need the sprite sheet.png because it contains our character, and the character sprites are directly pulled from that image from Kaboom. From that image are pulled the sprite character, so Kaboom still needs that. But for the map, for all the other types, so you could theoretically remove everything else and just keep that, and it would have been more efficient, considering that when you're making a web game, you have to see how much data you're sending. But those images are already very small anyway, because it's pixel art. Okay, so I'm gonna swap my images, my map, and my JSON file with the one I originally used. And now if I go and look at the map.png, you can see like the exact same map. And if you look at the map.json, you can see the various tiles. So let's take some time to explore how what the map.json, what the tiled export contains. So the thing that is very important is the layers property. So tiled exports with a bunch of properties, most of which are useless for our purposes. But the one that is useful is the layers property. So if the layer is a tile layer, it's going to contain the data property, and it's an array containing the frame number that needs to be displayed. 0 is the absence of a frame. For object layers, though, it's different. They don't have the data property. What they have instead is the objects property, which is an array containing every object that you've drawn in this layer. So the most important stuff is the x and y coordinates and the width and the height of that object. So this is useful for the boundaries. All right, so we have our map.json. Everything is fine. Now let's load our, just one thing I want to mention as well. If you want to add to a boundary, so this is often something you want to do. You click here to select an existing object when you are on the object layer. This little icon. Ignore this message for now, and then you can modify the width and height, etc. But you can also here in the properties tab add a name. Let's say I want this boundary to have a specific name. Let's say wall. And when the player hits this, we're gonna know that it was a wall. So you can use the data you pass here in Kaboom.js to know what the player is colliding with. So now I'm just gonna close this. It's no longer necessary. I'm just gonna discard it and go back to my original. So here is a bunch of objects that I've named specifically, like CS degree, PC, sofa table, player, TV, exit, etc. And for each of those, we're going to have a different dialog appear. Okay, so let's go back to main. And in main, what we're gonna do next is to import the actual map sprite, which is a single PNG image now that we have baked it into a PNG instead of drawing every tile separately. And then for the background, the way you can set the background in Kaboom.js is using the set background function. If you use this though, you need to pass in a color, and the way you can pass color is either via RGB, or you can use the color class and the from hex method to specify a hexadecimal value. The hexadecimal value we're going to use for this project is 311,047. And now if I run the project, so let's run it. I'm going to open up the terminal, type in npm run dev, and then once you do that, you can click on localhost, and you should have your canvas. So here we haven't done anything yet, and things aren't looking great. So we're gonna have to change the width of the div containing the canvas so that it takes the full screen. So you know what? Let's do this before actually writing the code, etc. So let's go back to our index.html, and in the style tag, I'm gonna add a couple of styles. So for the app div, so here take the IDs, and then we're gonna specify a width of 100 so it takes the full width of the page, a height of 100% as well, not 10%, 100%, and then overflow hidden so that scroll bars do not appear ever. We don't want scroll bars to appear in this project. If I look at the result, you can see that the canvas takes the whole space. Okay, now let's go back to main.js and then create our first scene, which is going to contain all of our code for that specific scene. I just want to make sure that for this project, because we don't have multiple different scenes, it isn't needed to create a scene, but I just want to show you how it's done in Kaboom.js. So to create a scene, you use the k.scene function. You give it a name. I'm going to call it main. And then what comes after is a function, which is going to be the code that is going to run for that scene. So here's where you write your logic for that scene. But before doing any of that, you need to specify using the k.go function what is the default scene. So by default, the game starts, it goes to the entry point main.js, it loads the various assets, set the background color, defines the scene, and then go to that main scene. Now here, this function we passed here is we're going to need to have it as an async function. The reason for that is because we're going to need to get the map.json data, and for that we're going to use a fetch call. So const map data is going to be a constant I'm going to name to basically get the map.json data we need in our JavaScript project. So here I'm going to use await fetch, which is a default web browser API. I'm going to explain everything in an instant. And then here.json. So here in one line, first we await the fetch function because it is asynchronous. That means that if you were to not use await, then your code, the rest of the code would continue to execute. So let's say I have some logic here. It would continue to run while fetch is still ongoing. We don't want that. We want to load the map data and not move the rest of the code here until it's done. That's why we await it. So basically waiting it. And then once we do that, we also need to convert it into a JSON object. And for that, we need to use the .json function, which is also asynchronous, .json method, which is also asynchronous. That's why we need also to await so that we don't move to the next line of code before it's done. So once map data is done and ready, we move on to the next things. So here I'm just going to create another constant called layers, and I'm going to extract from map data the layers property. So if we look at the map.json file, you can see that the properties, that one of them was layers, and this is really what we care about. That's why we create a constant. This is just for it to look cleaner. You didn't have to create a constant to get it, but yeah. And then here we're going to create our first game object, which is going to be our map. So in Kaboom.js, a game object can be basically everything, players, props, etc. What is a game object exactly? It's an object that contains different components. Those components can be positions, area, a body, or a specific sprite. And the way Kaboom works is that by passing in an array of components, you specify behaviors for your game objects. So it's basically an entity component system, I think. So how do you create a game object? There are many ways, actually two. The first one is the make function, which allows you to create the game object but not display it on the screen. The add function adds it to the scene. So either you have a choice. Either you make it and then later on you have to call the k.add function and pass in the game object like that, or you use the add function from the get-go and pass in your array of components here. So for the map, what components are we going to need? We're going to need to the sprite component to display the sprite, the actual map. The way we do this is simply by using the sprite component, which is offered by Kaboom, and passing it the key for the sprite you want to display. We specified the key in the load sprite function for the sprite for the image map.png. That's how Kaboom is able to know in advance what to display actually. Now, the next component we're going to add is the positional component, and it specifies the position that the game object will have on the screen when it is displayed. And here it is 0. Well, it's not necessarily only when it is displayed, just the position that it could have, regardless if it is displayed or not. And then if you use the add function, then it's going to draw it in that specific place. And then finally, we're going to need the scale component, and we want to scale up our map because it's pixel art, it's small, and we want it to be bigger. So a good practice I'm going to do is in the constant.js, I'm going to create a constant, exportable constant. I'm going to call it scale factor, and I'm going to set it to 4. So we want to increase it 4 times. And then in main.js, I'm just going to use that scale factor constant and call it. So it should automatically import the scale factor constant in case it doesn't add this at the top of your file. All right, now the next game object we're going to create is the actual player. And for that, I'm going to create a constant. I'm going to call it player. I'm again going to use the make function here. And the sprites we're going to pass is the sprite sheet itself, but with a default animation. This is something you can do when you have imported a sprite that has many frames, so a sprite sheet. You have access to this second param where you can specify a default animation, and here it's going to be idle down. Now the second component we're going to need is the area component. This creates a hitbox for our player automatically. And within you can add, so it's not very visible, so I'm just going to format this myself and then explain. So the k.area component allows you to create a hitbox automatically for your player, for your game object, but you can specify things within by passing in an object with the following properties. You can specify which collisions you want this game object, so the player game object, to ignore. And I want to, actually this is not necessary. We don't need that. This because in the project I did it a different way initially, but then I found a better way which doesn't require to really need that at all. But what we do need is to specify a shape. So by default it creates a shape that is roughly the shape of your sprite, but sometimes you want really to control the shape of your hitbox exactly. And the way you do that is by passing in an object with a shape property, and then use, for example, k.rect, which is going to create a rectangle. And then the first param is the position, which is a vector 2. A vector 2 is x and y coordinates. And you can specify here the vector 2 is going to be 0, 3. So we want the hitbox to be drawn from the origin and then +3 on the x-axis from the origin of the player itself. So the area is going to be placed slightly differently than the sprite itself, so that the hitbox is positioned properly. And for example, the player doesn't look like they are sinking in a platform or something like that. So this is something you have to play with yourself to determine which values are the best. And now the second and third params are the width and height of that hitbox. I'm going to go with 1010. It is on purpose smaller than the player's sprite, which should be 16 by 16. Now k.body, make sure is another component that actually makes our player a tangible physics object that can be collided with. And yeah, that's basically it. It's done automatically by Kaboom. Now we can also use the anchor component to draw the player from the center instead of from the top left corner. So this, the way things are drawn by default is that the X and Y coordinates are actually the coordinates of the top left corner of the object you want to draw. If you don't want that, you want the X and Y coordinates correspond to the origin, you use the k dot anchor and then specify which, so from the center. Now it's not the X and Y coordinates that are in the wrong position, it's the where the image is drawn from. So that's something. So for example, so the player, instead of being drawn from the top left corner, where the top left corner of that image will be the X and Y coordinate of that player, it's going to be the center, drawn from the center. So feel free to try and change the values or just try without, and then hit the F1 key to open the debug mode in Kaboom.js, and then you can see the difference. All right, now we need a K position component. We aren't going to specify a specific position now. We're going to do this later when we're getting the data from our map. We're going to use this spawn point. So here, if I go back to tiled, you can see I created a layer in the original called spawn points. And it's just this little pin with the name player, which determines where to spawn. So if I click on it here, you can see I've decided on this name. I just wrote it here. And then it's going to give us the X and Y coordinates. So we're going to know where to place the player. All right, another thing we need to do is to scale the sprite for the player, because for now it's going to be small. It's going to be a 16 by 16, and we want it to be at least the same, scaled the same as the map, so that everything looks right. And then finally, well, not finally, but we have what comes next is in Kaboom.js. If you want to hold properties for that game object, you can pass in your array of components an object, and then put whatever properties you want, and then they're going to be accessible directly by doing, for example, player.speed. If I create the speed property here, and I'm going to put it to 250. I'm also going to create a direction property that's going to be useful to know which animation to play. By default, it is down. And then is in dialog property, which is initially is false. So why we want this is that when the player is in dialog, that means that the text box is displaying text. We want to prevent the player from being able to move or do anything except read the text and click on the close button. All right, the last thing we're going to add to that game object is the player tag. So the way, actually, I'm not sure it's going to actually be useful for this project, but I'm just going to add it for now. It's when you want to check for collisions. If you give a tag to your game object, you can then use the onCollide function to know, okay, this collided with that tag, and that it means to run this type of logic. So it's a way to identify your game object. All right, so if I look at the result, nothing yet, of course, because we haven't put anything. Now that we have the player, etc., let's write the logic for actually displaying the boundaries. And then as we write this, we're going to write everything else we need. Okay, so here we need a for loop, which is going to iterate through the various layers we had here. And then depending on the layer, so if the layer dot name equal boundaries. So if we are on the boundaries layer, how do I know this? It's by looking at the map.json export, and then here you can have, for each layer you have a name key, the name key. This is how you know which name a layer has, if they have any. All right, so if I go back to main, I have the layer.name equal boundaries. And then if we're going to need a for loop, which is going to iterate through all the boundaries of layer.objects. Remember that when you're dealing with an object layer, which is the case for the boundaries, they have access to the objects property, which is an array containing all the objects in that layer. And the objects in that layer are just objects with x, y, and width and height properties as well. And now here we use the map object, and then we add another game object to it. So you can have child game objects by taking an existing game object and using the add function method on it. So what I'm going to do here is I'm just going to copy and paste it. It's going to be faster, and then I'm going to talk over the code. So we have an area component with a specific shape that corresponds to the width and height of the boundary itself. This comes from the tiled export in map.json. You see each object has a width and a height. Maybe we created this needlessly because the width is 0 and okay, no, never mind. Anyway, so you have your objects from here. And then I specify the specific shape we want, which is a rectangle, and you can do this by calling the making a new instance of the rect class. And then here you have as the first param the coordinates of that hitbox relative to the game object we're creating. We're just going to pass in an empty vector. That means we want the rectangle here to be at the same position as the overall game object. So yeah, the child game object, because it's different. Then there's the position of the game object itself, and then there's the position of the hitbox, so the area for that game object. And here, by setting the vector 2 to being 0, that means we have the exact same game object, game position, sorry. And then finally, we add the body tag. This is important so that we can add the isStatic property. What it does, it basically makes sure that the only way, that means that the player will not be able to pass over it. So it's going to be really stuck in that. Yeah, it's going to be, how do I say? The player will not be able to overlap. And this is how you do walls in Kaboom.js. And then finally, we pass in the name of the object, which was defined in the tiled export. This gives us the tag. It's going to act as the tag of the game object. This is how we're going to be able to identify what the game object is, what the boundary is. And this is going to come in handy later on because we're going to be able to know what to do when the player collides with it. Now that we have this, right below, if the boundary name of that specific boundary that we just created in Kaboom.js. So this, we're just taking the name out of the tiled export because we want to do something different. So if we want to actually here set the onCollision events. So if the player, we have the onCollide method on the player because we use the area component when creating the player. We're going to do boundary dot name. So the first param of the onCollide method is the tag of the second game object you want to check collisions with. We want to check the collisions of the player with this game object with the following tag, which is boundary.name. And then here we have a function that is going to run as the second param when, so it's going to run when when the collision occurs. And here we're going to set the player property is in dialog to being true actually, so that we're going to later on be able to prevent the player from moving while the text box is being displayed. And then here we're going to write this is actually where we're going to write the dialog, display the dialog, sorry. So is in dialog is here, it's from here. And then now if I go to, so let's put a to do here, to do. And let's go to utils.js, and in there we're going to create a new function that is going to take care of displaying the dialog. So export function display dialog, and then the first param is going to be the text, and on display end is going to be a method we're going to pass. Whoops. A function, sorry, that is going to run when the text is finished displayed. So we need two things. We need to get the dialog UI, which is basically the text box container. So I'm going to do document.get element by ID, and then text box container. All right. Once this is done, let me look if we have actually the markup for it. We don't. So let's go first create the markup for it in HTML. So here we're gonna have, first of all, inside of the div, the UI div, we're gonna have a p tag. That p tag is going to have the class of note. We're gonna later on create the CSS for it. And basically it's just an instruction to tap and click around to move. Now that we have that, I'm going to create a div within, and this is going to be our actual dialog UI. So I'm going to give it an ID of text box container, and then the styles here, we're going to actually, this is not a really good practice to do if you are in making a website, but I'm going to use the style tag here for a specific thing, for the display, setting the display to being none. You could have just created an ID here, a selector here, but because I'm gonna change this through JavaScript, I'm going to use this. But actually, I think you could just use a class list or something like that. So I create a class and then I remove it. But you know, for this project, I'm just not gonna bother with that. Okay, so now I'm gonna create another div from within. This div is going to, whoops. So let me do this. Maybe I should increase the font size a bit more. Yep. So the div here is going to have the class of button, actually text box. It's going to actually be the text box itself. And from within, we're going to have a p tag that is going to contain the text, and I'm going to give it the ID of dialog. And then we're going to have a class for it as well, which is going to be UI text. And later on, I'm going to fill those in. Right below, we're going to have another div, and then a button. The div is going to have a class of button container. This is so we can create a container where the button is always going to be on the right side of the screen. I'm going to give an ID to this button to being the close button when the player wants to close the text box. I'm going to give it the class of UI close button. Now let's write the CSS for it as well. Since we're here, I'm going to load our font. So in Kaboom.js, you can load the font if you want to display it via canvas. But because we're displaying via HTML the text, I'm just going to use the CSS for it. So font family, monogram, that's the name of the font. And then the source for the font is URL, and then it's monogram.ttf. And now it should be able to find it out here in the public folder. Okay, now the body tag, let's style the body tag as well. This is just going to set the font family for all of the body tags to using monogram, or as a fallback, you're just going to use monospace. So monospace is a font that should be already in your browser by default. The font size by default is going to be 2 rem. So 2 rem, 1 rem is basically the size of the font of your browser set by default at the root. So usually it says 16 pixels, and then you can decide, you can zoom in and zoom out in your browser control. So it takes here it takes the font size and multiplies it by 2. So 2 times the font of your browser. So that it will adapt. It's going to be responsive by default. And then here I'm gonna do overflow hidden. So here, instead of having overflow hidden here, I'm just gonna put it in the body so that the scroll bars don't appear. And then however, in the app selector, all of this is going to have a position of relative. This is so we can position it precisely with the X left and specifying the left and the top left and the right and bottom, etc. So that we can, it's going to, how do I say it? It's going to leave the document flow, and we're going to have much more granular control of where to put it. It's like if you would put an element on the canvas, you really control the X and Y position of that element you put in the canvas. So this is basically a way to achieve the same thing in Kaboom.js, in CSS, sorry. Now let's add for our, wait a minute, we have the text box. I don't think this is, I made a mistake. This should be an ID and not a class. And now below here, we're gonna have the class of text box, the ID, sorry, of text box, the selector for it. And here, by specifying position absolute, this is where you actually get the full control of where to put it by using the left property. I'm gonna put 10%, the right at 10% as well. So it's gonna look good. I'm gonna put the bottom at 2 view height. So it takes the view height and then it's a measurement relative to the view height. So it's going to adapt regardless of the screen of the user. The minimum height we're gonna need is 10 view height. This is what looked good. This is for the text box. You're gonna see in an instant when we'll see the result. The background, so this is the color of the text box. Let's put it white. Okay, so we have the background. The border radius, I'm just gonna put 3 pixels, it doesn't matter. The outline style, it's going to be black or solid. Is it the color? Yeah, solid. The padding is going to be 1 rem. As I explained, rem is based on the font size of your browser. And it makes it responsive, basically. And then, what do I need? Display flex. We're going to create a flex container. Now, this is some CSS knowledge. I assume that you have it. You have this knowledge already. If you don't, read up on flex containers. There are plenty of great articles and posts online explaining everything. So we're gonna have display flex and then a flex direction of column. So the children of our flex container are going to be positioned in the column. We're gonna set the flex wrap to wrapping so that when there's no space, it moves on to the next row. We're gonna justify the content to being flex start. This is so that the text within the text box starts at the top left corner. Align items as well. I'm gonna do flex start. I think I always mess up the justify content and align items. One is for the axis for which the content is flowing, and the other one is for the cross axis. So for both of those cases, we want it to start at flex start, which means it's top left, and yes, so it's top left basically. And then play with those values as you're gonna see how they are affected. Then word spacing is going to be 0.2 rem. This is what looked good. So Word spacing is self-explanatory, so the words appearing in the text box. And then here we're gonna have a little drop shadow. So we're gonna have a filter and then a drop shadow with the following arguments. Rem, and then a color RGB. So this is really took straight from the MDN documentation with just a bit of tweaking in terms of colors. Yeah, I don't really know. Maybe there's some explanations here. Yeah, you have drop shadow here. So here it is explained. Where are the params? Where are they? Does it explain? Okay. Okay, it's in French, by the way. Anyway, you're gonna figure it out by just looking at the docs, MDN docs. Type in drop shadow CSS, you're gonna understand. All right. Now, the UI text class gonna have a margin of 0, and then user select none. This is important so that the player cannot select the text and highlight it like that. Usually you don't do that in a game. And then finally, you have actually there's a couple of selector to define. So UI close button. I'm just gonna copy what's left. It's not much, and I'm gonna go over it. So UI close button uses this font family. For some reason, you need to specify this, otherwise it doesn't use the font, and I'm not sure why. Border style none, border radius 3 pixels, some padding, and then it should inherit the font size. Actually, maybe you could do inherit here as well, and should work. And then button container, it's going to align itself at the end of the text box so that the button is always going to be appear at the top right corner. And then the note is going to be, again, position absolute. It's going to be at the top left corner. So left and then top one VH. Display flex direction of column, etc. And then this is the color of the text. It's going to have that color. Yeah. If I save everything, look at the result, you can see that here you have tap, click around to move. Here it doesn't matter if you can select or not. But for the text box, we don't want you to be able to select the text. Actually, you know what? Let's also put it as user select none, just to make sure that it looks like a game. And that's it. If I now try to select, I cannot. You see. All right, now we have this. We can simply go back to our utils.js and write the rest of the logic we had here. So we need the following. So I'm just going to copy and paste that here. So we get the text box container, we get the dialog. So the dialog is actually the p tag here, where we actually put the dialog in. And then what we're going to do is we're going to set the display. So initially, remember in our markup, I put style display none. This is to make all of this invisible by default. When we want to show the dialog, we can use the style attribute here and set the display to being block, and this is going to make the text box container visible. So which by extension means that the dialog box is going to appear and the text is going to be visible. Now we're going to implement text scrolling, and this is very simple in HTML. This is the code for it. So I create an index which I set to 0, and then the current text is going to contain the text we're going to add to the element, the inner HTML here of the dialog box. Now inner HTML is not really recommended to use because you can be victim of cross-site scripting. So here in our particular case, it doesn't matter because we're not accepting user input. So it should be safe to not to use inner HTML, and it's kind of required because when we want to have our dialog box, you're gonna have sometimes the text that appears with links to your GitHub or things like that as attributes tag. And if we were to use inner text, for example, then those attributes that we pass, the links are not going to be rendered as links and will not be clickable. So here we use the set interval function in JavaScript. This is something that is basic, like vanilla JavaScript. And every 5 seconds, it's going to run the function here. We put a reference to that interval, that set interval event, so that we can cancel it, clear the interval when we're done with it. And then as long as the index is inferior to the text.length, so text.length is the text that we pass here, then we take our current text, we append the specific character at that specific index of the text, and then we put it all in the inner HTML. And yep, and then we do index plus plus, and then we skip this until the condition is no longer true, and then we clear. And that's basically it. Now we need to write the logic to have the onClose button, so that when the button needs to be closed, to do something like that, I'm going to put this outside, but still in the display dialog function. So if I paste, we get the close button by using a simple get element by ID. And then I create this function called onCloseButtonClick. It's going to call the onDisplayEnd function. This is useful because in this function, we're gonna set the player is in dialog attribute to being false without having to pass the player to this method, this function. So this is a handy way of using passing a function from the outside that has access to the player object, so that we don't have to add a third param here. And it doesn't make sense really. Why would you need the player to display the dialog? So that makes much more sense, and it's much more extensible. For example, if you want to do other behaviors when the display is over. And then here, the dialog UI style display, we put it back to none, so that the dialog section of the UI is going to be invisible. We set the inner HTML back to being empty. This, you could have used inner text, it doesn't matter. And then we clear the interval if it's not yet the case. And then we remove the event listener because we're going to add it. Okay, so we remove the function itself within the function. So it's recursive. So here we have, at the end, we create the event listener when there is a click, and then it runs this, and then it removes itself as the event listener. So that's it. Now if we go back to main.js, we can, here in the to-do section, have player, not player, call the display dialog function. It's going to import it automatically. Actually, it should automatically import it from the utils file. And then here, I'm going to pass the dialog data. So here for now, let's put test or to do. That's our text that we're going to display. And then here, we're going to have a function. And this function, actually, its role is just to set the player is in dialog to being false, so that the player can move again. And yeah, so look at the code here. And that's it. So if I think I have it, I collapse this. And then if, however, so we should probably put a continue at the end. So here, after all of this, we continue. That means we skip to the next iteration of the for loop. And then here, if the layer, the layer.name is the spawn points, well, the spawn points layer, which is where the player spawns. We're just gonna have for const entity of layer.objects. There's just one entity, but I'm writing the code to be generalizable so that if you decide to put more than one entity in the tiled export, it's gonna still work. And then so if entity.name is equal to the player, so this is going to be the player, so that's this is the name. I'm going to put player.position because I added the positional component when creating the player game object, despite having set it up to nothing. I can access the attribute position and set it manually after having created the game object. And here I'm going to use a vector2, which is just the x and y coordinate. And the position we're going to use, though, it's going to be very specific. It's going to be, whoops, not what I wanted to do. Yeah. So we're going to take the position of the x coordinate of the map. You do this by accessing the pos property and then the x coordinate. And then we're going to add the entity.x, which tells us where to place the player. And we multiply this by the scale factor because remember, we're basically multiplying everything by 4 so that everything is nicely visible and big enough. Same logic for the y coordinate. And then finally, here we use the add function in Kaboom to add the player game object we created in the scene. And then here you can continue, or it doesn't matter because we only have like 2 layers or anyway. So now that we have all of this, it's time to, I'm just gonna collapse all this section. We're done with it. And then here I'm gonna, I think that's right. Just some code to make the camera follow the player. So by default in Kaboom.js, you have the camera object already created. You can call the cam pause. So the camera system already exists. You can just control it. So I'm going to take the player world position. The reason we're using world position instead actually doesn't matter really because we haven't created the player as a child object. So if you're creating a game object as part of a child of another game object, you use world position to convert its position to being the position of in the actual canvas and not relative to the parent. So here I'm gonna use player.pos.x and then player.pos.y plus an offset of 100. So this cam pause is going to set the camera position to being this in the x coordinate and this in the y coordinate. Now if I look at the result, okay, I have the character, but the map is not appearing. I'm wondering why. Actually, why is the map not appearing? Is it doing everything right? Wait a minute. So if I go back to the top where we created the map, we have, okay, I haven't added it to the canvas, but you know what? Because it doesn't matter, let's use add instead to immediately add it to the canvas. And here we go. The map is displayed. If I press F1, you can see all the collisions. And for the specific objects, you're gonna have TV, sofa table, PC, resume, projects, exit, etc. Now the player cannot move. So let's fix that. And then also we're gonna need to add some other stuff like setting the camera scale. So depending on if the player is using a small screen or a big screen, we want to make the camera zoom a bit or not to compensate. So here, so let's actually write the logic for moving the player. So I'm going to use the k.onMouseDown. So because this is a very simple project compared to other tutorials I made, I'm not going to write those methods inside of the player. Let's just use the onMouse and take the player game object directly here. And yep. So when the onMouseDown is an event in Kaboom.js, it takes in a function and it will pass to it the mouse button that is currently being pressed. On mobile, it's just gonna consider a tap basically. And then here, if the mouse button is not equal to the left mouse click, or the player is in dialog, then we return early. That means we do nothing, we don't move. And this makes sense because we don't want to allow the player to move when a right click is pressed instead of a left click, because if they press both at the same time, they're gonna move twice as fast. It doesn't really matter because it's not a game we're building really, but just so you know. And here, if the player is in dialogue, of course, we don't want to allow the player to move while they are in dialogue. We want them to focus on the dialogue. Okay. Now for movement, we're going to need the following snippet of code. So let me just, okay. So that's all there is to it when it comes to movement. We need the world mouse position. That means because we're using the camera, the mouse position is going to be really according to the canvas and not according to the world. The world can be much bigger than the canvas because the world is much more than what is visible by the camera. And when you drag around this, what happens is that if you use the k.mouse pause, the mouse position directly, you're gonna at some point get stuck. I wrote a blog post article on my Substack. Link is in the description, so feel free to read it to get a better understanding. And by the way, subscribe to my Substack if you want for more like written content. Yep. So the only thing we need now to move the player is to use the move to function that is available on the player, because we have the, I think, the area component, the body component. I think because of the body component. So certain methods in Kaboom.js are only accessible once you have added certain components when creating that game object. So the first param is what is the target position you want, and we want the world mouse position. So we want the player to move towards this at the specific speed. And here we just get the speed from the player, which we defined here. All right, now if I look at the result, we should be able to move. And here we go. And then you can see we collide, and then to do, there's nothing that appears. And then to do again, to do. We haven't written the content, but that's almost all there is to it, you know. The next step is really to code the direction, the various directions. So make the player face a different direction, scaling the camera according to the device being used, the resolution. Otherwise, sometimes it's too big. It becomes too big. And actually putting the content inside of those text box. And that should be it. So now let's actually write the logic for scaling the camera, and then we'll write the logic for the directions, and then we'll add the text. Hopefully in that order. So here for the camera scaling, I'm just gonna, in the utils.js, we're gonna create another function right below. Export function set cam scale, and then here we just pass the context so we can know. We can compute how much we need to scale. So here I'm gonna create a constant. I'm gonna call it resize factor, and it's gonna have access to the width of the canvas. You can have access to the width of the canvas by calling the width method on the Kaboom context, and the height as well. And then we have this division to get a factor, and then if the resize factor is inferior to 1, that means we will simply set the cam scale. This is a Kaboom method, to being just 1. You can also do 2vec1, which is just gonna set it to 1. Otherwise, an else statement. You could either have an else statement, or if you want to be fancy, you can, and more clear, you can have an early return. And then here, right below, you can have k.cam scale cam scale, and then k.vector2, and we increase the scaling, so we zoom by 1.5 in both x and y transformations, so 1.5. All right, so now we have this. I'm going to go back to main, and where we're going to call it is, we're going to call this function first in two occasions. The first one at the beginning, we just do set cam scale, and then k, and also every time we resize the canvas. So you can know when this happens by using the onResize kaboom method, which takes in a function that is going to run when this occurs, and then you just can call the set cam scale and then pass in the context here. So let's look at the result. So here you can see everything is much better, and then as you decrease the thing, it's smaller, I think. Or is it? Let's take an iPhone SE, and then let's yeah, it seems to relatively work. Maybe I'm not sure. Let's gradually. Yeah. All right. Yeah. So it does. Yeah, it does change. Okay. Sounds good. Now what we need is to basically display the correct animations and sprite depending on the direction. So what I'm going to do to be able to know when the player should be facing left or right or any of those angles is to first store the mouse angle, which is just going to be the angle between the player. So you can do that by using the angle method of the position of the vector of the position of the player. So player.pos.angle gives you this, and then you can pass in the world mouse position, and it's going to give you the angle between. And with that, I'm going to first specify a lower bound, which is going to be 50, and a upper bound, which is going to be 125. You're going to see in an instant why we need this. And then we have our if statement. So here I'm just going to copy and paste and talk over it. So first condition, if the mouse angle is superior to the lower bound and inferior to the upper bound, and the current animation isn't walk up, then we will play the walk up animation and set the player direction to be up. If I look at the result, it's when the mouse is here. Imagine that you had a circle, and then here, if your mouse is within a certain range, actually for now you're not going to see the difference. So let's say my mouse, the angle here and here, so you're on a circle. As long as my mouse is still within those position, the up animation is still going to play. However, if my mouse exceeds, for example here, we shouldn't. Now this is not very clear for now, but let's add the conditions and then you'll see. So now what comes next is for the down animation. So it's the same thing with negatives instead. So now if I run and look at the result, if my mouse is here and I click mouse down, that up animation is going to play. If my mouse is here, the down animation is going to play. Now if I do, whoops. Okay, let's whoops. Okay, let's say I'm here. So if I do this and then I change, you see, it dynamically changes as long as I hold the mouse, because now the mouse position is within those upper and lower bounds of this imaginary circle in terms of angles. So now I'm just going to add the two other conditions. This is for the left and right, and then here, right below. So for the right, we take the absolute value of the mouse angle, and as long as it's superior to the upper bound, we flip the player X to being false. The flip X is useful because we only have one animation for the walking. It's called walk side, and by default it faces to the right. That means that if the player was flipped, mainly because of the other animations where we do flip. So for the left side, then we put it back to false so that the player looks at the correct direction. And then here, the same thing, but with flip X being true instead. And as long as the mouse angle is inferior to the lower bound, the absolute value. So we don't care about whether or not it's negative or positive, etc. So this is so it works on both sides of the circle, the imaginary circle. So now if I look at the result, you see, and you can have directional movement like that. Now you see that the animations of the player never stops, right? The way to go about that is to use the on mouse release method in Kaboom.js. I'm gonna paste it right below. So here, let me collapse everything here. And yeah, on mouse release. If the direction is down, we put idle down. If the direction is up, we put idle up. And if it's neither, then we put the idle side. And because we flipped the player, it's gonna point towards the correct direction by default. We don't need to do anything. So if I look here, I do this. Here you go. And then like that. And then I release the mouse. And then the player stops. And that's basically it now. The only thing is really the content here. And what we're going to do here for that is I'm going to go back to where I think it was here. When instead of having to do, we're going to hold the content of our dialog inside of a constant. I'm going to just call dialog data. Let me just look it up. So I'm going to copy and paste it and just explain to you how it works. And then you don't have to use the same text. So here you have a dialog data object with keys that corresponds to the tag of the boundary. So for the PC, you have this text. And then you can see me using the a tag here to have links, etc., as if it were HTML. And now here in main.js, instead of doing this, what you do is just you get the dialog data constant from the constant file. So it should import it automatically. Otherwise, do it manually. Here it is. And then here you just pass in the boundary name to select the correct text to display. And that's basically it. The project is done. If I go here and I go here, if you want to exit JS Legends portfolio, just close the tab. And then here, that's my TV. I've been watching tech YouTubers a lot recently. The Primeagen, Theo, Pirate Software, Milky, etc. And then here, that's my sofa. I like to relax and etc. And then you get the point. So if I open up the debug mode, you can see when there is the PC key here, those are the name of the various boundaries, and this is how we use them to as keys for our dialog data. So here, for example, this is my desk. On it is my resume. Check it out, and then it's a link with an A tag. So here, if I go here, the A tag, where is it? Constant. You can see the link to my resume, etc. So this is you're free. Don't just copy what I wrote here. Write your own dialogues to tailor it to yourself, basically. And that's basically it. Thanks for watching this tutorial. Hope it was something that you like to learn about. And yeah, thanks for watching. Feel free to subscribe for more content related to game development, specifically JavaScript or web-related game development, but hopefully not only. Maybe I'll try to do other types of development or with other stacks. So maybe making games with Lua or some stuff like that in the future. So yeah, feel free to subscribe and share this video if you found it useful. All right, thanks for watching. Bye. Hi everyone. In this tutorial, I'll teach you how to make a developer portfolio that is a 2D game. We're going to build this project using JavaScript, React, and Kaplay. So React for UI of the project. So for example, here I can go on the About section And if I go here, you have a modal with a link. And then if you press yes, it's going to open the YouTube channel here. And if you press no, it's going to close the modal, etc. So here for my Substack, if I click yes, it opens up a new tab. And that's that. So that will be the where we are going to use React in this project. Also for the UI here, where I can zoom in and zoom out. And also for Caplay, it's all the game logic. So being able to push around the various skill sections, the various project section, works experience, etc. These are all within Caplay. So Caplay is a library for making games in JavaScript using the HTML canvas element. And it makes it very easy to have graphics, collisions, etc. So it's a very easy to use library. So let me go over, just the portfolio. So we had the skill section, the about section with your various links, the work experience section where you can have a card with your experience, and then you have the project section where if you go here, you have relevant links to live demos, source code, etc. So to follow this tutorial, you're going to need to know JavaScript. You're also going to need to know React. By the way, I used React in this tutorial, but feel free to either use basic HTML and CSS because we're only going to use React for those simple models. The reason, not models, modals, I guess that's the correct pronunciation. But anyway, the UI is very simple. I just wanted to showcase that you can integrate an HTML-based UI on top of a HTML canvas game. You can do that with basic HTML, CSS, but you're going to have write a lot of boilerplate, I guess, or JavaScript code to do document, dot query, get element by ID, etc. So if you don't want to write all of that, I just decided to use React for it to go quicker. You can use any other front-end framework as well. So I still assume that you know React for this tutorial because this is what I'm going to use. And that's basically it. So I already made a similar project to this developer portfolio before. It was more on the game side, and this portfolio, this current one that you're seeing here, is really to address the issue that the recruiters don't have a lot of time to go through your portfolio. They don't have the time to play your game, I guess. So I thought of a better way to structure the portfolio so that we still keep the original idea of making it as a game, while at the same time giving the information, the relevant info as soon as possible. So that was the compromise I came up with. By the way, in this tutorial, I'm going to teach you not only the Caplay, so you don't need to learn Caplay, to know how to use Caplay before watching this tutorial. So the prerequisites are only React and JavaScript. But we're also going to learn how to make shaders, just a basic one. The tiling that you see in the behind is a shader. I'm going to explain what a shader is and just going to write it. It's not a course on shaders, but I would say it's a nice intro and how to use it within Caplay. Last thing I want to mention is that for deployment, I'm not going to cover how to deploy the portfolio online. The way you're going to learn how to do this is if you go on my Substack. I will put the link in the description. I have written a blog post on how to deploy a Vite chess game project on GitHub pages. So if you want to deploy the project on GitHub pages, you're going to have a tutorial here in the description. So my Substack is where I write written tutorials. So recently I wrote how to implement top-down shooter mechanics. So you can see here how it looks like. Maybe let me just jump into the final results. So if you want to see like that, if you want to learn how to make something like this, feel free to subscribe to my Substack where I put out written tutorials. So let's jump into the project. So I'm going to open my editor. I assume you already have Node installed on your machine and NPM. If not, feel free to watch another tutorial online on how to deal with that. So I'm going to create my Vite template. So by doing npm create Vite at latest dot, it's going to create the template for us, and you need to press yes. And then, so yeah, that's the command. For some reason, there's a visual bug in my terminal. And then select the React option. And then JavaScript. So now we have a bunch of files, and it's all good, but it's not what we want. Before going to modify the files, let's go in our terminal and install our Kplay. So Kplay can do npm install Kplay at 3001, which is the stable version of Kplay that I recommend that you use. The 4000 series version is in development and it comes with better performance, but because I want this to really use the stable version, so that it's stable and you can rely on it, I prefer to use the stable version for now. And for other projects where you need performance, feel free to upgrade to version 4000, but it's still in alpha. So that's something to take into consideration. So now that I have this, it's time to go into our folder structures. So here, the folder, the way we're going to go about it, that in our public folder, we're going to have a few things. We're going to have a configs folder, which is where we're going to create JSON files to configure the data that is going to be displayed in our portfolio. That means that, for example, titles, sections, etc., we just going to create a JSON file that we modify so that we don't have to modify the code base itself if we want to tweak the portfolio. Then we're going to have a fonts folder, which is going to be useful for our single fonts. And then another folders for logos, which is mostly for the skill section where you have the Next.js logo, TypeScript, etc. We're going to put all of this here later on. Then we need the projects folder. So here it's the screenshots of the various projects in the portfolio. So I'm going to put them here. And then I'm going to have the shaders folder, which is where I'm going to write my shader code and import it into Kplay later on. So it's as an asset, basically, because we're loading the file within Kplay later on. That's why it's here. And then finally, the sprites folder, where it's just going to contain one sprite, which is the player sprite. So I'm going to, again, put them all here. So the links in the description should contain all the assets you need. So copy that over here. And so basically, I'm going to put the link to the GitHub repo, and more specifically the public folder, so that you can just copy and paste all the files you need here immediately. All right, for the source folder, which is where we're going to write our code, I'm going to remove everything. So delete everything so we can start fresh. The first file we're going to create, actually, let's first start with our folders. I'm going to create a components folder. These components are going to be components we create within Kplay, because if you noticed in the project, so if I go back to here, there are like experience cards, sections, etc. And I thought I would divide them into components. Now, we're also going to have React components, which is different. This is for the modals and the buttons, etc. Okay, this is a mistake. It needs to be at the same level at the source. So you have two folders like that. And then a entities folder. But in this project, we only have one entity. So we have, only one entity. And then for the individual files within the source folder, we're going to have, of course, our main.gsx. So remember, because we're using React, it uses GSX and to render the HTML, etc. So that's the entry point of our project. So in index.html, it's here. Yeah. So it was already there before I deleted everything. I just wanted to start off fresh so you can know where every file comes from. Then I'm gonna have a constants.js, which is useful for holding our color palette. So let's go and right here create a constant called palette, with 3 different colors that corresponds to green, white, and dark blue, black near mix. So that I thought that was the right color combination. It's what looked good, so that's why I picked that. Then we have other constants that are going to come later on in place, but I prefer, to not introduce them now. So the next file we're going to need is a init game file, which is where we're going to init our game. I'm going to go over this later on. I'm going to have a Caplay context file, which is where we're going to initialize Caplay, the library we're going to use for our graphics, our game basically, mostly. I'm also going to have a React UI.gsx file, which is going to be the entry point of all of the React components we're going to use in this project. They're going to be added to this file, and then this file is added into main.gsx. And main.gsx not only initializes the React portion of the project, but also calls the init game function we're going to create in init game for our game. Then we're going to have a way, so by the way, something I forgot to introduce is that to have data shared between React, so the React layer, which takes care of the UI, and the actual game, I'm going to use a state management library called Jotai, which is very simple to use and allows us to create that bridge between those two layers. So I'm going to create a file called store.js. And by the way, mentioning this, we need to actually install it. So the way I'm going to do this is I'm going to install the specific version I used when creating this project. Follow the same so that if you follow this tutorial in the future, you're going to have something that works. So npm install Jotai, and then for the version, it's going to be version 2.10.0. Now, if you're following this using plain HTML and CSS or another front-end library, maybe you don't need to use Jotai, because the way I'm going to use it is very coupled to React. So once the store.js file is created, I'm going to need one last thing, is utils.js. Any utilities functions we're going to need. And we're ready to tackle the project. So once you have imported your assets, we can start actually working on the project. Okay, so now I have the assets that we need. These are, I'm gonna go over them later on. So I'm not gonna, actually, you know what? I'm gonna delete that. I'm gonna write them manually later on so that you can understand what we have here. So leave that empty, but for the fonts, we need IBM Plex Sans. These are going to be in the description for the logos as well. So let's go into our Caplay context, which is where we initialize our Caplay game library, which is going to create the canvas, etc. So maybe one thing, of course, I forgot to do is to go to the markup, the index.html, and make sure that here we have the div, which is the root of our project. Usually it's where React will insert all the UI. But for this project though, we need to modify that. We need to have this as the UI. The ID is going to be the UI layer, and it's going to sit on top of our canvas. So I'm going to create the canvas HTML element. And once I do that, I'm going to give it an ID of game. So now that we have the ID of game, maybe I should increase the font further. Yep. So now that we have the ID of game, I can go here in Caplay context and create our Caplay context, which is going to be the way in which we're going to use Caplay in all of our project. So we first create the context, which initialize the canvas, and then we call that function in the initgame.js file, and store the reference to the context into a constant, And that constant is going to be passed everywhere we need it, and it's where we call all the Kepler functions. We do this because there are some, we don't want to have conflicts between global functions in JavaScript and Kepler functions. So that's a way to avoid that. So here I'm going to import Kepler from the Kepler module. I'm going to create a function that I'm going to export by default, function called make Kepler context, and it's going to return a Kepler function call which initializes the canvas and creates our context. So the way you do that is by calling the Kepler function here and then passing in optionally you can pass in an array of an object with various options for your game. So for example, I want to make the global property false. That means you can only use Kepler functions, related functions from this reference, this context that is returned. By default, you could decide to import Kepler from Kepler and immediately start using Kepler functions because they're going to be globally imported. So that means you can just call them immediately like that. For example, you can call the load sprite function immediately like that. That's if you want to use global. By default, global is true, and the reason it's that is because it's easier for beginners to do that, to just use Kepler globally. I'm going to set the pixel density to 2. This is so that the game is sharp on any display. So on bigger displays, you want the thing to look nice, the game to look nice. So by setting the pixel density to 2, you can achieve this result. I'm going to also set the touch to mouse property to being true so that our portfolio will work on mobile as well. I'm going to set the debug mode initially to true, but I'm going to leave it to set it to false in production so that the user cannot access the debug menu. The debug menu, the debug mode can be achieved, can be accessed by pressing the F1 key by default. But here by passing in a key to the debug key property, you can specify a specific key you want to use if you don't want personally to use F1. Here in this case, I'm going to keep it as F1 because it's what I want to use. But if you're on Mac or maybe you don't have the F1 key available for this, you can set up the key you want. And then finally, we have the canvas, which is going to be you need to pass the reference to the canvas. By default, you don't need this. But since I want Kepler to use a specific canvas, so use this canvas, then you need to specify here the canvas by giving it the reference to the element. So I'm going to do a document get element by ID and pass the ID of the canvas I created in the HTML file. So now that we have our Kepler function that creates the Kepler context, I'm going to go to initgame.js. And in initgame.js, it's where I'm going to call that function. So first I'm going to create a export default an async function because we're going to load a bunch of JSON files, which is our config later on. And we need to use a fetch call, and it's better to use await, async and await in that case. So here I have a function called initGame, and its default is what is going to be exported. And then here I'm going to create a constant called k, which is going to hold our Kepler context. And this is where I'm going to call make Kepler context once here. And that's it. And now from here on, I can load our sprites, do things like that. So here we have our sprite, player sprite here. So if you want to load that, you would do k.load sprite, which is a Kepler function that loads sprites. The way to use it is you specify a key you want to use for a specific sprite. So I'm going to call this sprite player, and the path to get this sprite is to do relative path, and then sprites, and then player.png. So you can see this here. The reason I'm not mentioning the public folder in the path is because Vite takes care of that. You can omit the public folder because Vite will know that it's in the public folder. So Vite is the tool, the build tool we're using, which is what we did by doing npm create Vite at latest. So initially, if you had a single image, like if you didn't have a sprite sheet where there is multiple frames in a single image, you could just leave it at that to load it. However, since this is a sprite sheet and we want to specify the various animations, etc., you can add a third param, which is going to be the data, the properties you need to specify for the sprite sheet. So we're going to go over this later on. Let's instead finish the setup of our project before we go on loading sprites, etc. So this is where I'm going to go to main.jsx and set up the React portion of the project. So here I'm going to first get a reference to the UI div, and I can do that by using getElementById and UI, passing the UI ID. And I'm going to set the root of our React UI to being create root. So you need to use create root from React, from React DOM more specifically, and passing in the element you're going to use as the root. So here you need to actually do an import, create root from React DOM/client. This is how you do it in React. You create your root, and then you can do root.render and pass in a strict mode from React, which is a mode that will run certain things twice for debug modes, for example, use effects, etc., to help you catch bugs. And this is where we're going to write our React UI. So for now, let's keep it this way. So there's nothing, it's empty. So maybe let's have an element, maybe an h1 with hello world. And then here below, I'm going to call initGame, which is imported from my initGame file, which is going to create the Caplet context and then start using the Caplet functions and basically displaying our game. Let's run our project by doing npm run dev. And now if I click, now you can see that our React-based UI is not on top of our HTML canvas, but is above. And this is where CSS is going to come in play so that we can have our CSS overlaid on top of our canvas. So we have the basic setup done now. So we can start. Maybe one last thing is just to set up the React UI, which is actually where we're going to link all of our React components. So let's do that, and then we can consider that we have our setup done and we can start working on the various features of our project. So in React UI.jsx, I'm going to create my component. So default function React UI. And in there, it's going to return a fragment and let's say a p tag, which will say tap/click to move around, or to move maybe, or tap click around to move. That would be better. Then I'm going to here have what is below a to-do statement. Cannot make comments here, so I'm just gonna have a to-do. Oops. Bring the components, the UI components here. So now let me just see if I can make that as common. All right. And that's it. So now I can go back to main.jsx. Instead of hello world, I'm going to link that up here. So I'm going to have React UI as my component. I'm going to bring it from here. And we have it. All right. That's it. That's it. And one last thing I forgot to do is to have our style.css file. So for now, you can, you know what, I can either create the style.css outside here near the HTML and link it up like you would do in vanilla CSS, or you can create it within here, within the file, and import it to React. It's up to you. Let's do it the basic HTML way, so that in case you're following this tutorial without wanting to use React, it's going to be less jarring. So in that sense, I'm going to create a style.css file. And then here, we're going to fill that up later on when we actually need the CSS. And then to link that up, it's going to be, let's do it here. Let's link that here with a rel of style sheet. And then do a content. Here it's not, actually, never mind. It's type. This is a statement I always forget how the syntax of, because every time I need to import CSS in a project, in an HTML file, I just look it up all the time and copy and paste it. And then I never end up remembering how to do it from memory, how to link a CSS file. So this is how you do it. Link rel style sheet type text /css href and then the path to that file, which is at the same level here. All right, our project setup is done. We're ready to start working on the project for real. All right, so now I recommend that we start importing our assets. So let's go back to the first asset we wanted to import, which was the player sprite. Here I mentioned that we had the way you import the assets in Caplay is by using the load sprite function, passing in the key you want to use, passing in the path you want to, where the file is, and as optionally a third param, if you have a sprite sheet, you can pass a bunch of options to tell Caplay how to divide your image into single individual frames and how to define animations. So the way you do this is we have a first property called sliceX, which is the number of frames per row. So here 4 frames per row. So, and then slice Y, which is the number of frames per column. So here, if I dezoom, we have 1, 2, 3, 4, 5, 6, 7, and 8. Wait a minute, we have 8, yeah. We have 8 frames. Now that you have told Caplay how to divide your image into individual frames, you can specify the various animations by using the anims property. Now here, I'm going to copy and paste the various animations as I do not want to manually write them. It's going to take too much time, but I'm going to explain everything. So here, those are arbitrary names that I've decided to use for each of those animations. So the way animations work, the way frames work is that when you have a sprite sheet and it is divided by Caplay into individual frames, the numbering starts at 0 from the top left corner. So here, this frame is frame 0, this is frame 1, this is frame 2, this is frame 3, etc. This is frame 4, 5, 6, 7, 8, etc. So when you want to define an animation that only has one frame, you can just specify the name you want to use and the number of that frame. So walk down idle is simply the first frame here. And walk down is going to be the first 4 frames. So 1, 2, 3, and 4. Remember, it's numbered starting from 0, so it's 0, 1, 2, 3. So here the way you define that is you specify the from key, which is the starting frame, the to key, which is the end frame of that animation, and then optionally you can define if you want the animation to loop. And for all of the animation that has more than one frame, we want them to loop by default, so that when you call the play function on them, it's just going to play that animation indefinitely until we stop it. And this is ideal because we want to do that. Otherwise, the animation would play once and then stop. And let's say the character is moving in a direction. We want the animation to play as long as some condition is met. When that condition is no longer met, we want to change to another animation rather than just every time trying to play the animation again when it ends. So by having it looping by default, it's going to simplify everything. So here we have all the various directions, right up, or right idle, right down. Because remember, in this project, since the project is designed to be playable on mobile, so that you can move by using your mouse and pressing, we need to have 8 directional movement. So we have 8 directional sprites as well. So for diagonals, we have that included. So I'm going to show you how to implement that, how to change the animation by when it's needed, the direction, well, how to change the animation according to the right direction, sorry. All right, and now the other files we're going to import, there are plenty. So I'm just, again, copy and paste it. The project is open source, so you can just go into the project file and copy that manually, automatically, I guess, and paste them here, rather than typing out all of these paths. This is important to have the / here when you are deploying this, for example, on GitHub pages. So I recommend that you use the / here. So here we have a bunch of sprite images that need to be imported in our project. And that's it for now. And the next step is we need to have a to-do here where we need to import our shaders. Import shader. So now we have two options. Either I teach you how to make the rest of the game, or I teach you immediately how to make shaders. So how to make the tiled pattern shader you saw in the preview of the project here, which is cool. All right, so now we're going to write our first shader. So as I said, a shader is here in this project, it's going to be the tiled background you see behind the player and the sections of the portfolio. This is achieved by using a shader, and a shader can be viewed as a program or something that runs on the GPU that changes the colors of each pixel in the screen. So to be more specific, you can view it as the printing press. So imagine in the past you had people writing out manuscripts and copying the books manually like that. But with the invention of the printing press, you would be able to copy whole pages immediately by just stamping it with a pattern with each of the letters carved out. That way you could immediately print a new copy of a book, basically. And so it's the same principle with the shader we're gonna write here. It's a fragment shader. So there are three types, I think, of shaders, but the one that we care about is the fragment shader. Its role is a program that you write in a language called GLSL, which I'm gonna teach you the basics of. It's a domain-specific programming language to write the shaders. And the way we're gonna write the shaders is going to be specific to Gameplay. So we need to actually write the shape of our program in such a way that Gameplay can then integrate this shader. So just to recap, a shader, and more specifically a fragment shader, is a program that you write in a language called GLSL that for each pixel in your canvas, it returns a color. It is run in parallel. That means that The program itself runs for each individual pixel at the same time. That means that the program is not aware of what color other pixels are, etc. It's just like an input. You pass in the pixel, the color of that pixel. The output is the new color you want, and you can do some manipulations, etc. So I think, you know what, this isn't a course on shaders. So let's just jump into the code, and then I think it's going to be more, how do I say, more clear, at least what at a basic level, what shaders are and how they work, etc. in Kepler. All right, so in the shaders folder we created, we're only going to have one shader. You can create a file and call it tiled pattern.frag. So this is frag is the extension for the file because we have a fragment shader, which is a specific type of shader that modifies each pixel's color. So knowing this, the way we're going to write a shader is using a specific language called GLSL. I think it stands for OpenGL Shader Language. And it's I would say a subset of C, it looks like. So the way you write a shader, a fragment shader, is you create this function, specifically in Kepler, the way you do it. So you need to write your GLSL in a specific way so that Kepler can then integrate it into your project. So you first define a function called frag that returns a vector 4. So the return value, the return type, so it's a typed language, has the type here, vector 4, so it has 4 values. And it takes in params here. This is something specific to Kepler. It wants a fragment function to have as the first param a position, which is a vector 2. A vector 2 again for the UV coordinates. So UV coordinates are univariate coordinates. They vary from 0 to 1. So I don't really want to dive deep into what they are, etc. So let's just keep let's say it's just the coordinate system instead of varying from, you know, the image. Let's say you have a sprite. So it's an image, a PNG. Then you have the coordinate 0 and then some other coordinates depending on the length. Well, a UV coordinates just boils all this down into between 0 and 1. So things only vary between 0 and 1. So hope that clears things up. If you want to dive deeper into shaders, you can go to the Book of Shaders. It's a resource online that I recommend. So Book of Shaders. So maybe I'll try putting a link in the description. Like I said, shaders isn't my expertise. I usually use them just to achieve a certain purpose, and that's it. I don't really dive deep into shaders, but it's a pretty cool concept. So you can see online a lot of introduction to shaders. They make cool effects, etc. Alright, so we have our function definition here, and it must return a vector 4, which is the color, so the new color. And then something that is strange here is that in Kepler, the only thing we care about is this param that we're going to use for our tiled pattern. This, and then sampler 2D texture, etc., and even the position are not necessary at all. So here, what I'm going to do is I'm going to assign, so we have the UV thing, the UV coordinate, and it's a vector 2. And what I'm going to do is I need to write the following line. So this line, its purpose is to make sure that there is a certain aspect ratio. So here U time, U speed, U dot aspect, these are called uniforms. And you can think of uniforms as params you can pass from outside of the shader, outside of the GPU, I guess, which I think the shaders run on the GPU. So now what you can do is you need to define those params here. So typing in uniform, and by doing so, you're going to be able to pass them from Kepler. So in Kepler, when we're going to call the shader, we're going to be able to pass to it the the values we want for each of those params. So the first param uniform we want is a time one for storing the time. It's going to be a float value, and the convention is to use u underscore and then the name you want to use for your uniform. This is usually the convention, but you could find online where it's not the case. So the second one is going to be, we want one param for the first color we're going to use, another uniform. So here it's a vector 3 because in Caplay, you know, by default in Caplay a color is 3 channels RGB. The A channel, so the transparency, usually don't play with that in the color components in Caplay, but you're in fragments, in fragment shader, the vector 4 is the 3 channels, the 3 color channels, but also the transparency, which acts as the 4th. But because here we are taking those uniforms are going to be filled from Caplay, let's just use a vector 3. So here, color 2, and then another uniform vector 2 for the speed, and another one float, and then an aspect. This is for the aspect ratio we're going to use. This is important because depending on the width and the size of the screen, we want to change our calculus so that the tiled pattern is going to work well. And then here, we're going to have a uniform. The last one is the size, which will determine how many squares that we want at one point. So it's a tiled pattern, and you can have more squares or less squares. If you have less squares, it's going to be bigger, each of those squares, etc. So the first operation we do here is to make sure to, for each color, so each color, remember, this function runs for each pixel, for each pixel. And then for what we're going to take is the UV, for the UV. We're going to add to it I'm going to create a vector 2, which is going to be the time, but since it's going to now be a vector 2, it's going to have 2 components, and it's going to be added to this vector 2 and multiplied by the speed. And this operation is what is responsible for the movement in the tiling in the final project. So the fact that the tiles go down like that, it's because we're multiplying the time, and the time here passed from the uniform changes. It updates. And the speed is the speed you want to set it up. You could have decided to hard code this value, or like I did here, is to pass in as a uniform vector 2. And then this is added to the current value of the UV coordinate. And then we multiply by another vector 2, which is going to take the aspect ratio, which is just going to be in Caplay a value we pass the width divided by the height or something like that, so that the tiling isn't stretched, the squares aren't really stretched or too big, etc. So try it without and you're gonna see the difference. By the way, when we're working with shader in the context of Caplay, you have to refresh every time you want to test changes in shaders manually, because it's an asset basically. It's loaded as if it were an asset, as a PNG, etc. So maybe since I'm not a very good expert in shaders, I probably should have just, gave you the file and then you use it, but I thought I would just try to explain at least this part. So now we're gonna have a total float value, and this is just going to be like a bunch of math. So the way you achieve those tiling, etc., there's something called a sign distance function, which determines whenever or not a given point is within a shape, and this shape can be a square or triangle, and for each of those there is a specific signed distance field mathematical function, and depending on that you can have that. So you can basically draw your shape by placing, so if you pass to this function, this sign distance field function, a value, the value of your current UV coordinate, and it's going to compute it and know if the point is supposed to land within a shape or outside of it or at the border. And depending on that, you can color it differently. So that's how you're able to draw shapes. So I think, you know what, this isn't a math course, so I'm just going to copy the rest of the program, which is just this. So we have here a boolean that will determine whether or not it is even, and this will determine which color to pick. I think, yeah, which color to pick. So which color the square is going to be, so that we have this tiling effect in the final project. And this is modulo operator, and this is the floor function, etc. So this is math. So here actually we have a floor, then we take the x coordinate of the UV, we multiply it by the size. Here we do the same, and this gives us a total that we divide that we do the modulo operator on, and then which determines whether or not this value is going to be even, that the rest of the division is going to be even or not, and with that we determine which color we pass here. So here the reason we're dividing by 255 is that the colors that we pass from Kepler are vary between 0 and 255, which is the default values usually. But in fragment land, I guess, in shader land, we have our colors are expected to vary between 0 and 1 as well. And the reason why we have .0 everywhere is that the GPU likes floats, and it is recommended to always use floats and not integers. So sometimes it won't cause any issues to just have 1 instead of 1.0, but in certain graphics cards could not support that or not be happy with it and cause a crash or something like that. Like I said, I'm not an expert in shaders, so yeah. If you want to learn more about shaders, go to the book of shaders. I think that's the title. I will try to put a link in the description as well. Alright, so we have our shader. Now let's load it. So the way we're going to load it is by going to here, and we're going to simply write a statement. Like I said, it's like loading sprites, but just with shaders. The way you achieve that is to type in, let me just remove that. Let me put that here. So k.load shader URL. That's the name of the function we need to use. You select a name, much like the sprites. Here, if you're using, depending on which type of shader you're using, so I think depending on which type of shader you're using, if it's a vertex shader, then you pass the path to it at the second param. Otherwise, you set it to null. And if it's a fragment shader, which we have, you pass in the as the third param. And so if you were using a vertex shader, you would pass the path here and make the third param null. Otherwise, in our current case, you would pass the shader, the fragment shader as the third param and set the second param as null. So here we're going to have our named, which is tiled pattern.frag, tiled pattern.frag. Okay, now we have our shader loaded. Let's immediately display it on the screen. So let's write our code right below here in the initgame.js. Okay, VS Code is telling me that there is one file I haven't saved. Maybe I didn't save this. No, okay, I don't remember which file I didn't save. Okay, it's the constant, so let's save it. And now we're ready to get back into the project. So now it's time to use the shader. I really want to do that before going over the next part of the project. So I'm going to create our first game object. So a game object in Kepler is an object that is going to be displayed on the screen. It can have multiple components. So the way Kepler works is that it offers components that add behaviors and methods, available methods. So for example, if you create a game object, and then to create that game object, you use for example, a sprite component, that means that you're going to be able to display a sprite on that game object. And you're going to have access to methods like the play method that allows you to play certain animations. The way you create a game object in Kplay is by calling the context, the Kplay context, and using the add method or function, and then passing in an array of components. As I said, the components are offered by Kplay. So to display a shader, I do UV quad, which is a component, which takes the name of, actually, the UV quad is going to be the surface we want to display our shader on. And here I'm just going to do k.width and k.height. So k.width and k.height are functions from Kplay that gives me the current height and width of our canvas. Then the second component I'm going to use is the shader component, and this is the one we really care about. It's the one that is going to actually make display the shader on the screen. So here you pass in the name of the shader you want to use, that it should correspond to the same name here. Then you, as the second param, you pass in a function that returns an object. So here you can have this with the error syntax. And then pass in the values for your various uniforms. So for uTime, I'm going to use the time function in Kplay and divide it by 20. This will update. So this will pass every time times update, a new uTime is going to be passed to the shader. Then for the color, I'm going to name it color1. The names need to correspond to what's in the file, in the shader file. Just to make sure everything is understood here, you need to have a one-to-one exact name. So color1, and the color, to pass in a color, you can use the color constructor and then call the from hex method. This one does not need to be called with a new, so you can just directly use the method from hex if you want to pass hexadecimal colors. And here we can pull the color from our palette file. So if you remember, we not palette file, the constant file. So if I go to the constants, you remember this. So here I'm gonna do palette. Come on, suggest me. Here we go. This should be imported on the top of your file, and then you pass in color1 like that, and everything should be fine. Because remember, in this constants.js file, we have our colors as hexadecimal values. Then same principle for the second coordinate, or the second color, sorry. And you do it like that, from hex, and then pass in the palette color 2. And finally, the speed we want to move at. Here, the speed I decided it's a vector 2 because it will describe the speed in the y direction and the x direction, so horizontally and vertically. Here I settled for this for 1 minus 1. You can play around with the values and pick whatever you want. For the aspect ratio, we can achieve that by just dividing the current width of our game divided by the height of our game, by using the height and width function from Kplay. Finally, the uSize, which is going to describe the size of each of our squares in our tile pattern. Here I'm going to use 5. And then finally, we want to place this game object at the top left corner. By default, if you don't use the positional component, it's going to be put in that spot. And remember, in game development, things are drawn by default from their top left corner. That means that even if the tile background is placed at 0, 0, it's going to be fully visible on the screen because it is placed from its top left corner. Here I'm using the positional component and specifying 0, 0. By the way, a trick you can do is just pass in one value if it's the same in both positions. So this accepts a vector 2 or the two values, the two components, x and y, or 1 if it's the same across both x and y. Finally, I'm going to use the fixed. So the reason I'm using the positional component is that if you don't use it here, you will not be able to modify it later. So that's why you need to use the positional component to set the position in two cases. If you want the position to be different from 0, 0, then you need to use the positional component, and you need to use the positional component anyway if you want to be able to change the position of your game object after, even if you wanted to put it at position 0, 0 initially, which is the default position for a game object. Here, the fixed component, what it does is it will make sure that the game object is not affected by the camera, so it will always remain at the same place. This is ideal for backgrounds and for UI elements if you're making your UI within Caplay and not using HTML and CSS on top. So now we have our game object. It's not finished. So now we have a reference to our game object. I created this game object and stored it into the tiled background constant, which allows me to have access to a bunch of methods. One of them is the onUpdate method, which runs every frame, so 60 times if you have a frame rate of 60 FPS. And what I want to do is to make sure that the width and the height of the tile background always corresponds to the width and height of the window, even after being resized. And this is one way you could go about it. Another way would be to listen on resize. So when the window, the Caplay is resized, then you change. So I think that would be actually better. So let's try it out. So for now, just to show you why we need this, if I just set it up like that and look at the result, you can see that actually I picked the wrong colors, but you can see that we have our tiled pattern. So let's change that with the correct colors. So for here, it's not color 2 that we want to use, color 1 that we want to use is color 3. If I go back to the project, okay, in the end, it actually refreshes when you, no, because I changed within the JavaScript game, the JavaScript project. If you edit the fragment file, then it won't change. All right, so we have our tiled pattern. That looks nice. And one thing, the reason I wanted to showcase here is I open the window is that you see the aspect, the squares get stretched a lot. We don't want that. So here I'm going to use the K on resize, and what will happen here is that every time the window resized, so that's why it's a Caplay function, we're going to set the width of the tile background to be the width of the current screen. Remember, this only gives you the current width of the canvas, it doesn't update. So that's why here we need to recompute, I think, the aspect ratio as well. So here, if I do tile background.height, I need to update the height. Finally, for the uniform, you can access the uniforms after the fact, after having created the game object, by typing in .uniform and then the actual name of the uniform. It's the U aspect. And here, I'm going to change that to recompute the aspect ratio by doing k.width divided by k.height. Let's look at the result. Now if I open up debug mode, you can see that the pattern remained the same, and this is what we want. It's actually better than what I originally did, which was to use an onUpdate loop that runs every frame, but we don't need to run every frame. We can just run only when the window is resized, which is better for performance reasons. All right, so now that we have done this, we are ready to work on other parts of the project. All right, so now let's work on our player. So we will implement our player character that is going to be able to move around by clicking the mouse around. And there is going to be a bit of complexity because we need to be able to display 8 directional movement. So the first step is to create our player file where we are going to write our logic for our player. So I'm going to create a player.js file here. And in that file, I'm going to create a function, export default function, make player. That's the name. And we're going to pass to it the context from Kaplay so that we don't have to import it. We can just pass to it, to this function that its role is to make the player. And then we are going to pass as the second param the position of the player we want. So the position we want our player to be in. And finally, its speed, or their speed. So now we create within a constant called player, which is going to hold the reference to the player. And here we're going to use the add function to create a game object and pass in the following components. The sprite component to display the sprite player, and we can pass as the second param optionally default animation by passing in an object with the anim prop, and the default is going to be walk down idle. We're also going to scale, I should put a comma, k.scale our image 8 times, otherwise everything is too small. Then what we're going to do is create our anchor, use the anchor component. So the anchor component, what it does, it allows you to determine where to place, where the object is going to be drawn from. So initially I mentioned that by default things are drawn in the top left corner, but you can change that. And here I'm going to set the anchor to being center so that everything is drawn, so that not everything, the player that uses that component is drawn from the center instead of the top left corner. Then I'm going to use the area component to create a hitbox for my player. And here I'm going to specify a specific shape. So by default, it will create a square around your sprite, but sometimes it's not what you want. You want more specific shapes and a specific size. And the way you can set it up is by passing to the area component an object. And that object, you can specify the shape property. And here I'm going to use the rectangle constructor offered by Kaplay to create a rectangle which is placed at 0, 0 in terms of offset to the player sprite. That's why I use here 0, 0. And then, for example, if you want the hitbox to be offsetted in a certain way, to be like near the player but not exactly on the player, you can set specific values like 1, 2 or any value you want. And then the second and third param of that rect constructor is going to be the width and the height of your hitbox. And that's it. We are also going to use the body component, which I'll make sure that the player can have physics, so they can collide, not necessarily just collision detection, because collision detection is handled by the area component, but more so like being pushed around or able to push other objects, etc., or be affected by gravity. For this project, there's no need for a gravity because it's a top-down game. And then we have our positional component where we're going to just pass the pos vector 2 from the function. And then we're going to use a tag. So a tag is a way to identify a game object, and you can use it when you don't have a reference to that game object, but you want to check collisions with. So for example, if other elements like the section, the little like levers, I guess, or I don't know how I can explain this. If I go to the final project, there's a collision detection going on this square that enables the rest of the makes the rest of the section appears. So the way you can achieve that is by having the tag of the player and then calling the onCollide function that I'm going to cover later on. And then finally, you can pass an object. So not only can you pass a string like that to the array of components, but you can also pass an object, which will allow you to specify properties, default properties that you not default property, custom properties you can have for your game object. So this is basically, you could think of that as private variable, but they're not private, but as a way to set specific properties for each game object, which removes the need for you to create classes in an object-oriented way. You might still want to do that if you want to, to have private, public variables, etc. So you might want to wrap this into a class, etc. But it's up to you. So here I'm going to set two properties: the direction property, which is going to hold the vector2 that I'm going to use later, and the direction name, which is going to hold the current direction of our player. And I'm going to set up to walk down initially. And that's it at the basic level. There's still more to do, but one thing we need to actually do is outside, after declaring this game object, we need to return it. Let's hook it up to the... Okay, I didn't specify the speed. Here the speed is not here that we're gonna set it up. It's later on in the logic, so I'm just gonna have a to-do statement here with player controls, etc. So now let's hook it up to our game. So if I go back to init game.js, let's create our player. So here I need to create my player somewhere. Let's call it at the end. Let's call make player, which should be imported into this file, and then pass in the context, pass in the vector2. We want to put the player at the center. So vector2 allows us to create a structure that will define the position with the x and y coordinates. K.center is a Kepler function that allows you to get the current center of the canvas, and this is a how do I call it? This is a vector2 as well. And then here as the third param, the speed we're going to take is 700. You can play with those values and place the character where you want. The reason it's good to have the player in the center is the camera will also follow the player, and I think it's just the best setup. So now let's look at our result. Not this one, this is the final project, and you have our player here. So the next step involves implementing the player controls, and then once this is done, we can work on the sections or start working on the HTML React UI. So you might notice here that compared to the final product, our character is a bit too zoomed in. So this is something we're going to set up in our project at the beginning. So before even the tile background, depending on the screen size, we're going to pick a default camera zoom. So the way you can zoom a camera in Kepler is by using the cam scale method. So here I'm just going to create a simple function. That function is going to be called setInit cam zoom value. And it can be an arrow function here, doesn't really matter. And then I'm going to call the k.width and check if it's inferior to 1000. If it's the case, I'm going to call the cam scale function in Kepler and set it up to being 0.5. So if you're using JavaScript, you don't need to pass a vector2, you can just pass a single value. But in TypeScript, you're going to have an error. Here in this tutorial, not an error, but a warning, and or an error, I don't remember exactly. But anyway, here I'm using JavaScript, so it doesn't really matter ultimately, but what is passed here is basically well, you know what? In TypeScript, you either have to do 0.5 like that and pass both of them for it to work. So pick your option, which one you prefer. And so here we go, and we return early. And then in the case that the width is superior to 1000, then the cam scale I'm going to pick is going to be 0.8, which is what looked good. You can test those values and come up with whatever you want. I prefer honestly to just use like that with a vector2, and I'm just going to modify this here as well. So k.vector2, and then do that like that. And then, oops, I did not close it. And then, of course, call the function. So the reason we're doing this is just so I don't have to write an else statement. In hindsight, it's a bit of overkill. You know, you could have just decided to have an if and then an else. And I think it's better to, you know what, why bother with something like that? But usually it's preferred that if you can return early, that's always the best, instead of having else statements. But for this specific case, I don't think it's worth the hassle to create a whole new function just for that. So, and remove the return statement as well. Here we go. Now, if I look at the result, you can see that the character is appropriately scaled. So now let's implement the player controls. Here in this tutorial, I will not be using the controls that are in Caplay. So I'm gonna actually use the default APIs to enable when to click, the default vanilla JavaScript event listeners. The reason I'm doing this instead of using what is built in Caplay is that there is an issue when you have a UI, an HTML-based UI on top of the Caplay canvas. Sometimes when a UI element appears on top of the you know what? I think it's not necessarily the fault of Caplay for this, but you actually need to use the focus out event listener so that you can easily go from clicking on the UI and then going back to the game. Because by default, if a UI element appears on top of your Caplay game while you're clicking, so let's say I'm pressing somewhere on the screen and clicking, and then let me just show it to you so that you can know. So if I go to the final product, when I do this with my mouse, if the modal appeared here and I press no, it would continue to move as if the input never stopped. And that's why I had to use the default vanilla JavaScript APIs instead of relying what is in Caplay for this specific portion. All right, so what we're going to do is create first a is mouse down function, not function, variable, and set it to false initially. Then I'm also going to get the document, the actual canvas element. I actually need that. And I'm going to set an add event listener on it that is called focus out. So does it explain what it do here? Basically, when the focus is no longer on the canvas, I can run some logic. And here the logic I'm going to run is just set the is mouse down variable to being false. Now, for the rest, I'm just going to copy and paste it. And you also need to do this for mobile. So here are the various event listeners you're going to need. So mouse down, when the mouse is down, you set is mouse down to true. For mouse up, false. For touch start, true. And for touch end, false. And then here, I'm going to use the player reference I had up there. And I'm going to create a call or add an on update loop, which is going to run whatever is in this function. It's going to run this function every frame. And here, let's make our logic to follow the player. So here, I'm going to first have a statement that checks for the camera position. So if the cam position, so the way you access the camera position in Caplay is by using the cam pause function. And then you can have it returns a vector too. It gives you the current position, but it also allows you to set a new position for the camera by passing in a param. So if you just call it, you get the current position. If you call it by passing something, a vector2, you modify the position. And because it's a vector2 that what's returned, you have access to a bunch of methods offered by vector2s. Vector2s here in this context is a data structure offered by Caplay, so it has methods you can use offered by Caplay as well. So the EQ method, which allows you to easily check for equality between two vector2s. So here I'm going to pass the position. You can access the position of the player, the current position of the player, by doing dot pause. So, but to do this, you need to actually have the positional component defined. And then in that if statement, so in the case where the camera position is not equal to the player position, that's why the bang sign is here, I'm going to use a tween. What a tween does is to gradually change a value to a destination value. So I'm going to have the initial value being the current cam position. I can get that by calling cam pause. I'm then going to have the target destination as player pause. I want it to be done in 0.2 seconds. And then you need to pass in the modifier function, which will take care of modifying the function, the values. So here I'm just going to pass the new position, the gradual. So for each gradual position, it's going to pass a new position here. And I'm going to modify the camera pause to reflect that new position until it arrives at the target position. Finally, you need to select an easing function. An easing function is the rate at which the change is going to happen. And here I'm just going to pick a linear easing function. Okay, now that we have our camera logic ready, we should actually start implementing the movement of the player so that we can see our camera following the player in action. How I'm going to achieve this is, first of all, I'm going to, at every frame loop, I'm going to set the direction property of the player game object to a vector2 that is 0 and 0. So initially, if you remember, what we had in here is the custom property direction, which would set this to a vector that is 0, 0, which this vector describes the direction in the x and y coordinates. So at each frame loop, so every time onUpdate is called, we set it up to being 0, 0. Then we will get the world mouse position. World mouse position. So I'm going to create a constant, call it world mouse pause. And the reason we need to do that is that we need to have the camera, the mouse position in the world, in the game world. That means affected by the camera. Otherwise, you would have the screen mouse position by default. That means where your mouse is on the screen, on the canvas itself, not in the actual world. If you were to simply use the mouse position when you would click to move the camera, things wouldn't work well. So that's why you need to use Kaplay's toWorld function and pass to it a vector2, which is here in this case we want the mouse position. And now what we need to do is simply have an if statement. If the isMouseDown variable, you remember this variable was declared initially here, so here. So if that isMouseDown variable is defined, we're going to set the player direction to be the world mouse position, and then more specifically minus sub, by using the sub method on vector2s, sub the player position, and then we want the unit vector. So let me explain. This needs a bit of a math understanding. So we have our world mouse position. We subtract to it our player position, and this is how you basically can calculate the direction that is the direction between the mouse, the direction the player needs to have to go towards the mouse position. And the reason we are then normalizing our vector2 here with a unit is so the values are between 0 and 1. That actually -1, 0, -1 and 1 between those values, so that we can scale that vector according to the speed. Otherwise, you couldn't be sure. Like, you could have a vector that isn't normalized, and then when you're going to multiply by your speed, you're not going to have the same speed as if you were to move in either the left or right direction, for example. So that's why we normalize. because the scaling, the actual speed is, we just multiply by this vector. So this is something you need a bit of math understanding. And yeah, so now that we have that, the only thing we need to do is to actually have the, I think that's it for, yeah, we need to call the move function. So right below here, I'm going to leave a to-do message. This message is going to be for implement animations here. And then for now, let's worry about actually moving the player. And that's why you use the move method, which is available on a positional component. So when you use the pause component, you can use the move method. And you can pass in the x velocity or y velocity. Alternatively, you can pass a vector to. Yeah, so actually it's just that. Our vector 2 is this one, the direction, so player.direction. And then we're going to simply just scale that vector by using the scale method on vector on position on vector 2, sorry. And then I pass in the speed that we had initially passed as a param to our make player constructor or function. So now if I test this out, you can see that our character is moving. So now what's left is to actually deal with the various animations. And I want to make a diagram. So the way our animations are going to work is, imagine you have this circle. And this circle is within our Cartesian plane. So we have this like that. The x-axis. This is the y-axis. Whoops. Okay, I want it to be symmetrical as much as possible. So now here our values, since we have our vector, directional vector, etc., which varies between -1 and 1. That means the value here, maybe I can draw, yeah. So here we have, on the x-axis, we can have a value of 0 up to 1. Actually, never mind, -1. So 0 is at the center. We can have 1 at the end here, -1 here. For the y-axis, same logic, but the further you go down, the further the value of y increases. And here it decreases the further you go up. So that's why it's -1 and 1 here. And this is a convention in GameDev because the Cartesian plane is inversed on the y-axis. So that's why the arrow is pointing downward. Now that we have this, so the way we can swap animations is we check in our circle where in the range of positions of direction the direction vector is. So for example, for these values, so for any direction vector values that are between, let's say, this range that I've drawn here, we want to play the walk right animation. And now same logic applies here for the walk left anim. And now we also want to have a piece here and a piece here. So let's say we have this drawn this way, and then for this one we gonna do this like that. So in this zone, let's say, we want to have the walk right up animation. Sorry for the handwriting, I'm writing this with the mouse. And here we want, so there's a specific values, you see. So here the values of y could be -0.5. So, and then we can use that as our upper or lower bound for this section. So we have the walk right up anim that is going to play here. And here we're going to have the walk left anim, walk left up, sorry, anim. And whoops, terrible handwriting, sorry. And the rest here of the circle, this zone, let's say we want to play the walk up anim. So by doing something like that, we have basically our logic here for displaying the various animation, the various 8 animations. So here the same logic applies. This is going to be walk left down or down left. This is going to be walk or walk right down. And then finally here, the anim that is going to play here is going to be walk down, down, and then walk up. All right. So this is how the logic, and then we have the values here that serves as our upper and lower bound. So it's not 0, it's just a number here. And through experimentation, I've come up with certain values. So in practice, if I go to my code and implement our animations here, this is how it looks like. So the first if statement I'm going to use is this one. So if our player direction is equal to a vector 2 of 0, 0, and our player current animation. So to get the current playing animation, you do get cur anim and then the dot name, and it will give you the name. And if that name is a string, include, so I can use the includes method. If it includes idle, so because we have the bang sign, it's the reverse. So if the animation that is currently playing does not have the idle name because of this, then this is a mistake. This is not what we want. Here, we're going to play this animation. So let me just copy and paste it here. I'm gonna play according to the current direction, the name here. So the name of the direction. So for example, initially it's walk down, and that means that if the vector is 0, 0, that means the direction vector is equal to 0, 0. That means that the player is not moving, and we're going to basically make it play the idle animation according to their current direction. So this direction name is not set yet. It's the other if statements that comes after that are going to take care of setting the direction. So this is where something would like to move faster. I'm just going to copy and paste the code and then go over it. That way, things are going to be simpler. So here, paste that. So what do we have here? So let's start at the first one. So this was the first if statement we had. Then this is our first if statement for when to pick on the direction walk right, which is also the name of the animation. So we check if the player direction on the x-axis by doing .x, because this is a vector 2, we can access the x and y coordinates separately. So we can do that. So we're making sure that it's superior to 0, that means we're actually moving to the right, and that the y value is superior to minus 0.5 and inferior to 0.5, which was the range we want to play the walk right animation. Same logic with walk left, but on the other side, so making sure that x is inferior to 0. And yep, and then same logic with walk up and walk down. Those are the basic 4 directions with these intervals, so 0.8. These values, 0.5, minus 0.5, are what looked good after testing. So these are the intervals that I think would makes the most sense. So I just came up with them by trial and error to see like which value would work well. And then for walk left up, it's this condition where we're making sure that the y is superior to minus 0.8 but inferior to 0.5, which corresponds to be just outside of the bounds, the area covered by the walk left animation, and so on and so forth. So here, just for you to be able to copy, so I'm just gonna, you can pause right here and copy the other if statements. And then by setting the direction name, which is the string here, we are going to need another if statement to actually play those animations that are not idle. So what I'm going to do is add another if statement and do the following. So here, so if the current animation is not equal to the direction name, because in this case, in our case, I decided that the direction name of our player, so direction name is a property that I created earlier on here. It should have the same name as the animation name in the way I designed this project. So in the case that the direction name is not equal to the current animation being played, then we can play the animation with that name. This is for two reasons. So to first play the correct animation, but also to prevent replaying in the already starting right animation. So for example, if the correct animation is already playing, we don't want to replay it again because it will reset the animation to the first frame. And this will make the animation never actually start because it's always restarting. Because remember, the code here that we're writing is within a onUpdate loop, which runs 60 times per second if your game is running at 60 FPS. Now, one thing I forgot to do is that there is a case we need to handle. So when we were moving diagonally, usually in top-down games, you move faster diagonally. So moving like that, sorry, there's a bug, is faster than going straight up, straight down, left and right, etc. To fix this, there is a mathematical way of doing it where you can just multiply your vector by a constant, and that constant is 1 to the square root of 2, I think. I don't actually remember, but yeah, you multiply that. So this factor, it's a constant. So here, I'll just add this diagonal factor, and the value, if I remember correctly, I'm not sure I remember the correct value. So I'm going to go to the constant, and it's 1 slash, so it's a fraction, math dot square root of 2. So this is a constant. So I've written a post explaining the math behind this. You can find it on my Substack, but at the end of the day, you don't need to calculate this all the time. You can just use this constant. And by the way, since later we're going to need to add a way to zoom in and out the camera, I will create those two constants called zoom max bound and zoom min bound, which describes the limit of zooming in and out the camera. So this is something we need to implement later on. So now here, since we have a diagonal factor, we need to import it. Now it never suggests me the correct thing, unfortunately. So I'll have to do import diagonal factor from constants. All right. So now that we have this done, we have our movement set up. It's time to test things out. So I think it has refreshed. And now you can see that the correct animation is playing depending on where I'm going. Yeah. And then you can do this like that. So that's how you implement 8-directional movement. Now the next step is to actually start working on our UI in terms of React. So all of our React components and how to hook them up with our Jotai store. So Jotai is the state management library, which offers a store that allows us to communicate data, to send data, and just communicate, basically make data available on the React layer to the React layer and vice versa, so that we can communicate between our game and the upper UI on top. So let's work on that next. So let's set up our Jotai store. So the way we're going to go about this is create a store.js file. We should have already created the file, but it should be blank. And in that file, we're going to set up all the various data we need in our project for the UI and basically general data stuff. So let's get started. I'm going to first use an import statement and imports two things from Jotai, which is the create store function and the atom function. I'm going to explain what they are for in a moment. So from Jotai, import these. Then I'm just going to close this, and then here we're going to create our first atom. So an atom can be viewed as a piece of data you want to have a setter and getter for it, and you want to make available in the store. So the way we're going to do that is I'm going to create a constant. Let's have our first atom being is a boolean that determines if the social modal is visible, and the convention is to suffix the name of the constant with atom, and then you can call the atom function and pass in the default value. So the default value is going to be false here. And you know what? I'm going to copy and paste all the other ones we need. I'm going to go over them. So we're going to have a selected link atom. So here first, what does the is social modal visible atom corresponds to? It corresponds to a data, a boolean that we need to actually know in the final product. When, for example, we hit here, the social model is this. It appears with a link and then tells you if you want to open it or not. And if you click no, it should, close. And if you click yes, it should open up the social media on a separate tab. So that's the purpose of that. The selected link atom is to pass the link you want to open. The selected link description is to, pass the description. It's an empty string by default. The is email modal visible atom is whether or not the email modal is going to be visible. So the email model is a component that's very similar to our social media model, but this time around it just tells you if you want to copy the email to your clipboard, and if you say yes, it will show you a message that it is copied, and then you can go. And then here the chosen project data atom is going to be data that you pass when you select the project to open. It corresponds here to in the final product in the project section. When you collides with this circle, this is the model. It should have access to the data for the live demo, source code, links, etc. So that's the purpose of this. Now the camera zoom value is also for tweaking the zoom of the camera within the React buttons. So here in React, in the final product, it's the plus and minus button here, which is going to be a React component, those two. So they need a way to set the value, and Caplay needs a way to get that value. That's why it's an atom, because we're going to use the store in a moment to be able to pass this data between the two, between the React layer and the game layer. So we need to export our store, and the way you do this is by creating a constant that you're going to export and calling the create store function. So to use that in React, to use the store in React, we need to go to our main.jsx. And here we had initially the strict mode and then our React UI. We can wrap our React UI with a provider from Jotai, which is this wrapper. So the import statement should be added. And then once you have the provider, and then you wrapped it around your React component, your entry point React component, here is React UI. You need to pass in the store you want to use, and it's going to be the store from our store.js file. So this is how you pass in the store to the React layer. And as for the way to access the store in vanilla JavaScript, the way we're going to go about this is let's go to the player.js file. And in there, we're going to do a specific thing. So here we have our logic to make the player move, etc. And it's here we're going to set up the store values for our is the social media open, etc. So if either models, either the social media one, the project model, etc. is opened. So here we have those three booleans here. If any of those three are open, we want to disable any player controls. So we don't want the player to be able to move while those model are opened up. The way to ensure this is to go to player.js, and in our onUpdate loop, what we're gonna do is basically get those values from the store. And this is a good example of how to use Jotai in vanilla JavaScript. So here we go. So the way I'm gonna go about this is here, right before, so right after our camera following the player logic, but before here, I'm gonna have an if statement, and I'm gonna call the store and import it from our store.js file, and use the get method. And then here you need to import the is social modal visible atom from the store, and that's how you access a specific data. So you don't just import this. You cannot just import this and then read the data. You need to use store.get and then import this as well. So it might be a little bit redundant, but for setting, it's the same logic. You use the set method with this, and then as the second param, the value you want to use. So here our if statement is going to have three things. Either this is true, so we get the data, so it's a boolean, or the other two are true. So let's say store store.get, and then is email modal visible, and then finally store.get is project model visible. In any of those cases, if it so happen, we're going to return early. The goal of returning early is that whatever comes next will never run in this loop. It's a way of basically preventing the logic for moving the player to even run in the case that any of those three models are opened. Now, you could argue that instead of having three different, values here, you could have one for models. The reason is in our React components, we haven't created them initially. It's here in React UI, we're going to call them and place them, and then depending on if we want to show them or not, we're going to decide this. But you could have, I think, architected the solution differently, where you would only need one. So maybe it could be an exercise if you want to improve the code base after the tutorial. So now that our store is set up, we're ready to start working on our UI components. And before we do that, let's go to our style.css file and just add some necessary styles so that at least our UI is on top of our game canvas and not as it is right now above. So the way to do that is let's first have our basic CSS reset. So I'm just going to copy and paste that. So to use the border box sizing, which includes padding and borders, I think, when you're setting the width, because by default, when you set the width of an element, It does not include those paddings and border, which are then computed on top of what the width you have specified, which might not be intuitive. Then we're going to import our fonts that we're going to use here. Something to keep in mind, and I think I will, yeah, something to keep in mind is that for the fonts, you need to make sure that you have a relative path like that. I think in the deployment blog post I've written, I have mentioned this so that if you don't do that, you're going to have an error when deploying, and it's going to be a bit tough to know what went wrong. Then I'm going to have the root element, the root pseudo selector, to set the font family and the font size, and then our color palette. Here we have an extra color that is, I think this one, that is a bit lighter. This is to give an effect, a highlight effect when you click on a dark button, so that it lights up a bit. Then we are gonna add this to our body in HTML to have a full height with a zero margin, and basically this allows us to have our game take everything. I don't think this is necessary. You know what? One thing, maybe it is. We actually, I think, you know what? I'm not sure if we need this. But actually, you know what? To center our modals, etc., probably needed. So let's keep it. And then with the background color is not relevant here because we're almost never seeing the background color because the game loads almost immediately. But I thought I would just keep a color that is like this one, the dark color, as our background in case it takes some time to display the canvas. So if I save this and look at the result, I'm curious if there's going to be any difference. So you can see it's on the left side, which is not what we want. So you know what? Here in our React UI, for now we have this. So I recommend that we are just going to add the rest of the CSS as we work on our UI components, and that would be more intuitive and easier to follow along. So that's the next step, is to actually start working on our various React components, which are our models. So the first modal or component we're going to work on is, let's work on the camera control. So the menu that allows us to zoom in and zoom out our camera. So I'm going to create a camera controller.gsx file. And what this will do is return our component, which is going to be export default function. And then we have a camera controller, that will be the name. And it's going to return some JSX. So I'm going to have a div, and then I'm going to have two buttons. So one button, which is going to be a plus sign for zooming in, and another button for zooming out. Now here is how you're going to see the Jotai state manager coming in action to update the state variables we have defined. So I'm going to first need to get the current zoom value of the camera. So I'm going to do const and create a cam zoom value state variable, and then a set cam zoom value. And I'm going to pull this, instead of using a use state, I'm going to use a use atom from Jotai, which allows us to access the cam zoom value atom, which actually holds the current zoom value of our camera. Because remember, we need to have this data accessible both in our React components and in this React component, and we need it to be accessible in our Play or vanilla.js code. So now that we have this, using the useAtom hook will allow us to have a setter and a getter for that state. And now here in the first button, I can define a onClick, and this onClick is going to return a new zoom value, which is going to take the current zoom value and add to it a 0.2 increment. Why 0.2? It just felt good. You can play around with values, but I think these jumps are the one that felt good. Now what we need is to have an if statement that will check and make sure that the new zoom value we just calculated is within the zoom max bound and zoom min bound that we defined in our constant.js file. So if I pull that up, where is it? Constant. Here we go. Those two things. So if new zoom value is inferior or equal to the zoom max bound, and and the new zoom value is superior or equal to the zoom min bound, so this should be also imported. Make sure that it is imported. Then we can actually set the cam zoom value to that new zoom value. And then for the minus button, the logic is the same, but the only difference is that we reduce instead of adding. So I'm just going to copy and paste this. All right, so now that we have that, it's time to actually implement it in the Play layer. So here, if I refresh, I actually didn't add the component. So in our React UI entry point, I'm going to call the, I'm going to import the camera controller component and pass it here. So if I look at the results, we have our buttons here. Now it's not styled yet. I'm going to work on that in a moment, but let's first make sure the functionality works. So to get the functionality to actually work, we need to go back to our init game file. And here we set the cam scale, but it's not there. It's right after we need to write a logic and update a general onUpdate loop. So you can do k.onUpdate. So onUpdate can both be a method of a game object, which is going to run a loop every frame. So gonna set the listener on every frame on that game object. So if the game object gets destroyed, then this onUpdate will also be destroyed. Or you can have a general onUpdate loop for the whole game. And this is what we're doing here by calling it directly from the context. So this is the function, Play function. For performance reasons, if you can, always prefer to use an onUpdate as a method of a game object, if you can. But here it doesn't make sense to do that. It does make logical sense to do it. And there isn't a performance penalty to pay, really, in that specific case. So here I'm gonna get my camera zoom value. Now you can see that in my React UI, I call this cam zoom value. So I should probably stick with the same conventions. So cam zoom value. And here I'm going to use the store. And I want to get the following. So From the store, I want to get the camera or cam. Okay, so I have camera zoom value atom, but I called it cam zoom value. It doesn't matter, you know. So I'm gonna get the value, the current value. This is very important because when the value will change because of the React component, so because we clicked on the plus, the on update will get the new value and will change it basically. So here we're gonna have an if statement that will make sure to check if the cam zoom value is not equal to the current cam scale. So that's the way to get the zoom value in Caplay. Only in that case where it's not equal that we are going to set the cam scale to that cam zoom value. And then, yeah, here again, you pass in a vector2. If you were to use TypeScript, you should probably do k vector2 like that, if you don't want to have an error. All right, so now that we have done that, the logic should technically work. Let's try it out. So if I go back and there's an error, or maybe there isn't. Is there a reason it disappeared? The player disappeared. You know what? What we need to do, I think that's due to the default value picked. So if I go to my code, you can see that in the store.js file, we have the value of 1 as our camera zoom value. And initially, we would like to start at 0.5 on smaller screens and 0.8 on bigger screens. So here in our logic here, we can do a store.set and make sure the camera zoom value atom is initially 0.5, the value of the atom. So not the value set here, but it should be the same in this case. So really logically, it would make more sense to do this first and then set the actual cam zoom in Caplay. And then we do the same thing here as well. But this time with a value of 0.8 for bigger screens. This is what I think looked good. If I try this out, we have the value. If I click on the plus button, I zoom. If I click on the minus button, I de-zoom. So this is much better. All right, we have a working zooming feature. Now let's style this correctly because it looks very ugly right now. So if I remember how I did it is that in our React UI.jsx, let's create a class. So first let's style our, you know what? Yeah, let's first style our message here to tap click around, and then we'll style the camera controller. So here I'm gonna use a class name. I'm gonna decide on the name controls message. And now if I go to my CSS here, I'm going to use the following CSS for this. So let me just find it though. Here is the value. So we're going to use this class and we're going to have a position fixed. This is essential so that we can place our element like we would on a canvas using the top of and left. You can think of this as your X and Y coordinate. So how much offset it from the top and how much from offset it from the left. 3 view height, 5 view width, an opacity of 0.4, a font size of 1.2 rem, which is the root EM, so the font size at the root. The max width we want is 40 view width, and we don't want the user to be able to select that text. So if I look at the result, do we have something good? Yeah, we have tap/click around to move, and we cannot select the text. Now let's style our UI for the camera controller. So the way we're going to go about this is I need to first add the correct classes. So I need to refer to what I had originally. So here in our div, we're going to have a class name called camera controller. And for our buttons, we're going to have a class name called camera controller btn for buttons. And we're going to use that twice. So here and for the other button as well. Now let's add that CSS. So here, it doesn't really matter the order in our specific case, but for a camera controller, I'm going to use this rule, a rule set. So we use a flex container, position fixed, so that we can place it however we would like. Make sure the Z index is superior 1 to the canvas so that it's on top. And I don't think this is needed by default. It's going to be on top. The gap, to have a gap between our buttons. So if I look at the result, you can have our buttons here at the top left corner, top right corner. And now it's time to style our buttons. So here below, I'm going to add another rule set. I'm going to use the CSS variable for our color. So those were defined here. So these are called CSS variables in case you're not familiar. So we have the color of a button, the background, the border, and then the border style solid, the border radius. This is okay, pixel for radius, but for the font size, we want to be twice the root font size. And the width is going to be 12 width. And finally, the opacity of 0.4 so that the UI is a bit transparent, which is, I think, the standard in mobile games, because you have to click on where the game is, because there's no analog controls, only touch controls. So here we have our buttons. So here, now it should be nice to have an effect where when we click, it gets the opacity becomes 1, so that we can have a nice effect that will add visual feedback to the player that they have clicked on that button. So to do that, we're just going to use the pseudo selector active. So when the button is active, which happens when it is clicked, we're going to set the opacity to 1. So here, if we do this, you can see that it gives that nice effect. So that's it. We have our UI for our controls done, pretty much done. So now what's next is the models that we need to design. All right, so let's create our various models. So in our React components folder, I'm just going to create from the get-go all the files we're going to need. So an email modal.jsx file. We're going to also need a project model.jsx file and a social model.jsx. Let's start with our social model. So here, in terms of logic, we're going to have a export default function social model, and then we're going to have a state variable called isVisible, which is also going to use the atom. And then here, use atom. And here we want the is social model visible atom, which is what you want imported. Of course, don't forget to import the use atom hook, which I didn't do here. So import use atom. And then we need a selected link. And this, because we don't want to use a setter, you can use atom value instead. And then you can just have the selected link atom. So use the use atom value hook when you just care about the value and don't care about setting it as well. And then finally, we have a selected link description. And then here I'm gonna use the atom value. Yeah. And then bring in the selected link atom. And then I'm gonna have an array which is going to contain our buttons, so, and the data related to that. So let's have an ID for each of our buttons. So let's start with ID 0. The name of our button, yes, yes option. A handler for that button, so that when it is clicked, we run this function. And this function will run from the window context. It's going to open the link. So open selected link with a target.blank for it to open in a separate tab. And then we're going to set is visible to being false so that the modal will immediately close. And then our second button is going to have an ID of 1, and it's going to be called no, and when it is its handler when it is clicked. So this is just something I created for myself to create those buttons dynamically right below. And here we would immediately set the is visible to false. So we're just closing the modal without opening any links. And now we can return some HTML, or I mean JSX. And we're going to have if we are going to only show this model if the is visible state variable is true. So the way you achieve that in React by doing is visible and then the JSX you want to use. So here we're going to have our model, and in that model we're going to have another div. And then here I'm going to have a message that says, do you want to open this link? And then we're going to have a span tag right below and pass in the selected link here, which is going to display the link that we want to open. And then a p tag to display the description. Finally, we're going to have a div that is actually going to contain the buttons. And we're going to create our buttons by iterating through the buttons array. And for each of those buttons, we're going to return some JSX. So here in this case, because we're returning, we can just do a parenthesis instead. And we're going to do a button tag, return a button tag on each button in that array. And then this is where it's important to pass a key, because React needs to know a unique key so that it is always rendered in the same order even when the state change. So that's why you have that's why I created unique IDs for each of my buttons by creating this ID prop. And then here we're going to have an onClick, and we're going to pass the button handler we defined. And then finally, within the button itself, we're going to pass the name, button name. And that's it. Now let's add various class names that we're going to use to style this component. So I'm going to have a first class name called modal. I'm going to have a second class name called modal content. I'm going to have a third one here for our buttons. I'm going to call it modal button btn container. And finally, for our buttons, I'm going to set it up, here, right after class name. And then I'm going to call it modal button. And that's it. Let's add the relevant CSS for that. So for the CSS that we need is the following. So we need first the model. So right above, let's say we have it right after the HTML. We're going to create the model class, which is going to be this one. So what this does is we have a flex container, we justify the content and align the items for it to be centered. We use position fixed to be able to place the element like on the canvas with specific top and values. So here top 0, that means we actually don't need to you know what, I think this might not be necessary. Z index of 1, I think it's important, but by default, since our canvas is right after the UI in our HTML, it's given that the UI is going to be displayed first. So you know what, I'm going to delete those things, and let's see if it will cause an issue later on. If it causes an issue, I can just, add it. Overflow auto, so that in the case it overflows, I don't think it overflows at all in this project. But one thing so I'm going to remove it. We want the model to take the full width and height. By the way, it is called model, but I think this isn't. This is misleading. It's the container of the model, because the backdrop filter here that will blur things with 2 pixel is basically the background, the container that contains the model. And that's why we have the model content, which is the actual model itself with the border, etc. So the background color, I should have probably selected proper names, but you know what? I think I should probably just have used Tailwind CSS. Things would have been much simpler. I wouldn't have to come up with names for CSS classes. So we have background color, border color here, border style solid, adding margins, some border radius, and padding, and then finally max width and height. So here we're using pixels, not ideal. Here you should use a relative. I just realized that I forgot to swap this with actual relative units. So feel free to do that, because except for this, I think, because we don't want the model to be too big, I think it doesn't hurt in the end, because in the project, the final project, I have tested it on mobile and desktop and did not notice that I used pixel values, specific values instead of relative units. So yeah, you can tweak this as you want. And then finally, we have our button container, our modal button container. It's not finally, we still need the button. So here a simple flex container with direction column to display our buttons as columns, and then finally the model button and the model button active and the model. I guess there's more. So here I'm just gonna paste it all because I don't want to spend too much time on this CSS. So we first have the model button here with the various font size, margin top, min, etc., min height, max height, border, etc. when it's active. And so that's when we click, we have that nice effect in the same way as we had with the camera controller. And then here for the content, within the model content, so the h1, the span, and the p tag, we want the color of the text to be that color, the color 1, which is this one. And that's it. That's the styling, all the styling we need. Now we won't be able to test that out just yet. So let's work on the other components. And then when we were going to actually work on the elements within the game, within the caplay layer, that will result in opening up the model, then it's going to be easier to test. So yeah. So maybe I shouldn't have started with this logically, but anyway, it's too late. Let's finish those components and then we can work on the rest. All right, so let's continue with our email modal. So for the email modal, I'm going to do the same thing we did with the social media modal. So here in this case, we're going to create a component. So we're going to do export default and then email modal. That will be the name. Then I'm going to have a state variable, which is visible, and a setter for that state variable, set is visible. Now I made a mistake. It should be a function. And then here I'm going to use an atom, import it from Jotai, and then import the is email. I don't remember the name actually. I need to go to my store.js. In there, it was is email modal visible. That's what I need to import. It should is email modal visible. All right. And then it should also import it from the store. Then one thing I want to address is that the logic that we're going to have here is going to be very similar to the one from the social media model. But the reason I'm making it as its own component is I usually prefer to repeat myself up to 3 times. So usually if you're familiar with design principles, there is one called dry, which is don't repeat yourself. And what I prefer to follow is don't repeat yourself over 3 times. So dry ot. I guess that would be the new acronym. The reason for that is that sometimes you do a premature abstraction and then you realize that in the end, the 2 cases that you thought were similar and could be abstracted out as a single one was not, those cases were not similar enough, and they're going to make your abstraction leaky in the sense that it becomes harder and harder to maintain. So sometimes it's very good to copy and paste mostly the same code up to 3 times, and then if you see that you're repeating the same thing up to 3 times, at least you know that, hey, more than 3 times, you're pretty much sure that you have a way of making an abstraction that could cover those cases. So here in our case, we're going to also create, so that was just a side note. Now let's continue. So I'm going to create a onCopy message state variable, which will hold a message that will just tell the user when we copy my email. So the way the email modal works is that when you click on it, you will have a message that will appear that you have copied it to the clipboard. So here it's just going to use, in this case, a normal state variable with an empty string. So here we use the useState hook from React. And then here we're going to have our buttons. And here, just to go faster, I'm going to copy and paste the code I had originally. And it's the same structure. So you have an ID, a name, and then a handler. And in this case, for the yes button, we will use the Navigator API, which is default native to your browser, and write to it, to your clipboard, my email. So this is how you do a email copy. And I'm going to set the copy message on copy message to email copied to clipboard. However, if you press the no button, I'm just going to run this handler, which will make the modal invisible. And now for our HTML or our GSX, we're going to have exactly the same thing. So here again, I would like to just copy and paste rather than manually type it out to go faster. And then I will explain any concepts or things that are new. So here we have same thing here. Then the class names are the same, and then it's just like displaying the email. We have the modal button container, so everything is similar to what we have with the social media model. And that's it. That's all we need for this component. So the other component, the last one, is the project modal. Then again, we're going to have something similar, but I think this time around it is slightly different. So here again, I would like to just copy and paste the code and go over it with you. So I'm going to copy it and go line by line. So here we have our import statement for useAtom value and useAtom for our state coming from Jotai. And then we will first get the project data. So this is something we declared here, chosen project data atom, which is something that we're going to set from within the gameplay layer of our game. Here for now I just put some default values, but I think this is not necessary at all. You could decide to just leave this as an empty object and then set it up in that in the gameplay layer. We're going to do this when we're going to implement that aspect of the project where when we collide, maybe showing an example would be better. So here in the project section, when you hit this circle, it opens up the modal and loads the information. So we're passing from Couplay to React that we have the Sonic themed infinite runner. By the way, this is a tutorial I made on my channel. So if you're interested, subscribe and watch it. Same thing for all the projects showcased here. So if I go back to the project, I go back to the project model. This is what we have here. I'm using the useAtom value hook because we don't need the setter. So that way we just can have a single constant like that. And then we are taking the atom from here, from the store. Then we have again the same principle with isVisible and setVisible with the isProjectModel visible atom. And then we do the same logic with the model content, model, and then every class name here is the same. Here the difference is that we have an h1 to display the title, and then we immediately have a list of buttons that we dynamically generate based on the link data. So project data.links is something that comes from here, from the project data. You can see in here the shape I've decided is that you have a key, a property for the title, and then you have a property which contains an array, which are all the various links. And for each link, we have an ID, a name, etc. The ID, the reason for that is to have unique keys in our elements here so that React can always render the elements in the same order. And then here, because they all do the same, they do a window.open. I felt that we didn't need to specify a handler like we did with the email modal and the social modal. Modal. I can pronounce it properly, I think. And then we have the link data.name here. So here, if you look at the shape. All right, so that's it. And then we have finally a final button. So this is dynamically generated. And then we have this button that always is, no matter how many buttons we need to generate here for this particular project. And it's going to be a button to close the modal. And that's it. That's the full extent of the React components. So that's it. From now on, it's just about hooking them up into our game and displaying the correct data. So that's it. All right. So now for this part of the tutorial, I would like to spend some time to create our various section. So there's about, skill, work, experience, and project section. And then we're going to create a single component within Couplay to do that. And then we will work on each of those, the rest of those section individually. So if I go to what we have currently, it's just an empty void. So that's why I thought it would be a good first step. So to do that, we're going to first go back to, in our component folder, components, those are components that are actually game objects within Couplay. Which are the visual UI elements or text elements, etc., that are visible within the canvas. They're not in the React layer. So for that, we're going to create a first file here, which is going to be I think I'm going to call it section.js. And then in section.js, I'm going to create a default exportable function called make section. So here we're going to have to pass the context, the Caplay context, and then we're going to pass a position. And finally, we're going to pass, a, pause vector 2 would be a better name. Section name for that specific section that we're going to display, either it's the about section or the project section, etc. And then finally, an on collide handler that is going to run when the player collides with the section switch. Why do I mean by the section switch? Is the following. So those square act as switches that display the rest of the section. So now to create our game object, I'm going to first store it into a variable, a constant, and then call the add function with an array of components. We're going to create a rectangle with a width of 200 and a height of 200. And we're doing this by passing the rect component and specifying optionally a radius of 10 for it to have circled array corners. So you can pass this as the third param within an object. And then the other components, we're going to have the anchor component so that the game object is drawn from the center. We're also going to have a area component for it to have a hitbox so we can test collisions on, detect collisions. We're going to set the position with the pause component and pass in the pause vector 2 in the param for the position. We're going to have a color component to set the color of that rectangle, and here we're going to pull the color from the palette, and it should recommend palette. Oh, come on, it's not. I have to import it here. Import palette from constants from constants. I think that's the file. Yeah. And then from here, we're going to use more specifically the color 1, which is the dark bluish near black color. And then as the tag, we're going to use the section name as the tag, which you remember that a tag in Caplay is just a string. So that's why you can do this. And then here we're going to create a child game object. So this is a new concept if you're new to Caplay. So far, if you're being introduced to Caplay with this tutorial. So here, what it is exactly is that it's the way to add children. Game objects can have children, and the way you add them is by using the add method on that game object. And like the add function from Caplay, it works the same way, but the game object that is created will be positioned relative to the parent game object. And when the parent game object is destroyed, if it ever gets destroyed, the child game object also gets destroyed. So here, I'm going to use the text component and display the section name. So with the text component, you can actually display text in the canvas. And then as the second param, you can specify a bunch of properties like the font, the size, etc. Here I'm going to have a font of IBM Bold. If you remember at the beginning of the project, we imported the font 2 times in the HTML and CSS, and at the same time, and also in the, in Caplay. So here, if I go to the initgame.js file, you can see that we imported it here. You might wonder why we do this twice, and I think because the way fonts are loaded is that Caplay is not aware of what is loaded in the HTML and CSS. But you know what? I'm not really sure, and I've never actually tried. So I'm going to remove that and see if it works. You know what? I cannot test that right now. So I'm going to keep it. I think it doesn't work. You have to load, compared to some other frameworks and libraries, for example, Phaser, where you can use the fonts loaded in HTML and CSS. I don't think you can do it in Kaplay. You have to use the load font function to load that font, but I'm not sure. And hopefully I'm going to remember to test this when we finish this component and actually add it to the scene so that we can know and have our assumptions cleared, confirmed or not. So here I'm going to have the font of IBM Bold and the size of 64. So I'm going to specify this size as being 64. And then, yep, so we have our size of 64. And then I'm going to set the color of that text being the same as the color of the switch. So palette and then color 1. And then what I'm going to do is set the anchor to being center so that the text is drawn from the center, and the position that is relative to the parent game object, which looked good, was 0 by 150. Remember, the lower y gets, the higher it is on the screen, in the canvas, because of the inverted coordinate system in the y-axis. And then finally, if the onCollide function is defined, it is passed as a param here. So here we're going to make this optional by having it by default null. So in the case you don't want to have this. So if the onCollide function is true, because in JavaScript you can pass functions as params, there are higher order functions. So that's a pretty useful feature that comes from functional programming. And here, so if the onCollide handler is defined, what I'm going to do is I'm going to create my onCollide handler here, which is going to just have a reference. Actually, this should be called a onCollide controller, which will hold for the section name the onCollide. So there's too many onCollides here, and it might be very confusing. So let me just write it out, and I'm going to explain you, or just copy and paste the code, just to go faster, and I can better spend some time explaining to you. So here, instead of handler, I decided to change my mind and call this a controller, which is closer to what the documentation is, names things. So what is happening here? I have my game object, which is a section. Since it has the area component, it has access to the onCollide method, which is used to check collisions between game objects. So here you pass the tag of the game object you want to check collisions with. And here I passed the tag of the player. And the second param is the function that is actually going to run. And I want to run the onCollide function passed to the function, the make section function, constructor or function here that makes the game object. So this is so from the outside we can call that, and then in that function we're going to display what will happen, create all the other game objects when the collision occurs. And we only want this collision to occur once, because after the, so maybe I can explain this with the live demo. Once you have collided once and displayed the section, we don't care to listen and check again for collisions. So for performance reason, even though the performance gain is not great, it doesn't change either way. But also because we don't want to create the same section twice after. So for example, imagine I didn't have the code here that would run this one, the onCollide passed here once, and then not cancel it. Then what will happen is that every time I collide with the skill section, for example, this would be recreated, and then we would have duplicate game objects, and performance would go to the ground. So it actually saves a lot of performance. And the way you can cancel this on collide is that by storing it in a constant and then calling the cancel method from within, because this on collide returns, this method returns a controller that allows you to control it basically, and it has access to the cancel method. So this might not be clear right now, but it will hopefully become clear in a moment. So here I'm going to return the section game object. So basically returning the full game object here. This is something I do by default for this. We might not need it. But anyway, enough talking. Let's just try it out. So in initgame.js, maybe here somewhere, we're going to add this section. Here I'm going to call the make section function. And you can see that the return statement was not necessary immediately because we were just calling it. But this is something I like to do because sometimes you need the reference, and we're going to need the reference in other components we're going to create here. So yeah, this isn't necessary in our current case, but I will keep it. Just in case in the future, if you expand the game, you might need to, see what was returned and access it, like that. So I called make section, make sure that this is imported on here. So yeah, and then I'm going to pass to it our context. Then the position I'm going to use is going to be k.center and then x, so the center position in the x coordinate. But for y, I will do k.center.y and then subtract to it some value minus 400. And our first section is going to probably be the about section, where we're going to display all the social media icons. So then I'm going to pass as the name about, and the onCollide function is going to be the following, and the param here we're going to pass the parent, so we can add to the sections other child game objects. So this is something that might look strange. So if I go back to the section, you can see that we're passing this the actual game object here that we created to the onCollide passed in the param, and that acts as giving access to the parent from the outside here. So that the parent here refers to the section. It could be named whatever you'd like, but the first param, any first param, will contain the parent game object of the section. So basically the section itself. So here, let's create, you know what, let's leave it empty for now. Let's look at the result, if anything is displayed. Okay, it doesn't like the import statement is wrong. So in section, let's go back here. Import palette. Okay, we needed 2 dots because, yeah, we are one folder back, and then, yeah, it should be one folder back. Anyway, now we go back to here. Everything is all right. Let's look at the result. And we have our about section here that appears. Nice. So let's work on adding game objects to that. And then once the about section is done, we can work on the other sections. So, or you know what? Let's do this just to have things logically separated. Let's generate the other sections, and then we're going to create the components we need for each of those, which are the social icon component, etc. So I'm going to call make section again, pass in the context. Then for the second one, I'm going to have the following. So I'm just going to copy and paste the position, which is a vector 2. Then the name is going to be, I think this one is to the left, and it's the skill. I think it's the undefined section. It's the skills section. Skills, yeah. So let's have a skills section. Then once the skills section is done, let's pass an empty function to be our here handler. Then I'm going to copy that again and paste it. This time the position I'm going to take is to the right. So let's put this to the right. And it's going to be the experience section. And then finally, one last copy and paste. We're going to have the following position. Let me just copy and paste it here. Plus 400. The lower the value of y, the higher on the screen. The higher the value of y, the lower on the screen. You're displayed on the screen. And yeah, so our experience this time around is going to be the project section. So feel free to add and remove sections as you see fit after the tutorial. So now if I look at the result of the actual final product, you can see all of our sections. So now let's worry about the about section and more specifically creating the components for that. So the social icons, etc. So here I tried, so to come back to the font loading discussion we had earlier, it seems that if you have an HTML font loaded within your CSS, you don't need to load it again in Capplay. But I had some issues, sometimes the font would not load, etc. So I recommend that you just keep the load font in both Capplay and the CSS just to make sure that the font is actually loaded. And the reason you need both instead of just one is that remember that even if, for example, Capplay takes care of loading the font because the UI is on top of it, you know what? Maybe we can actually do that this way. So instead of loading the font within CSS, what if we would just let it within Capplay only? And then if I go here, never mind. I don't have the UI, but you can see that the font appears here. I tap click around to move, and there seems to be no issues. So I think that would be the correct way to go about it. So have the font loaded in Capplay only, and then make your HTML UI should be able to use that font as well. Now this wouldn't work, this solution, if you have you need to display the UI first rather than the Capplay game. In that case, you're pretty much stuck with loading the CSS first. So that's it regarding discussing this issue. So now has come the time to build our icon components so that we can use it in both the social media icons, but also for the skill sections for all the skills. I'm going to create a file, call it icon.js. I'm going to create another file that I'm going to call skill icon, which is going to be different. So skill icon.js and a social icon.js. Both social icon and skill icon are going to be based upon the same base icon.js game object. So here, if I go to icon.js, the code for this is going to be the following. So I'm going to create a default function. I'm going to export, this function called make icon. I'm going to pass in the k, the parent of that icon. So parent game object, its position, pos vector 2. And you know what? To go quicker, I'm going to copy and paste the code and then explain over it. I think it would be a better use of our time here. So what do I have here? I have first an import statement towards the palette to get the colors. I create a function called makeIcon, which will make our icon. And it first takes as the first param the context, a parent game object to which to attach this icon, the position of the icon you want to have. This position is going to be relative to the parent. The image data. So basically, the image data is going to be an object that has a name, width, and height property. and allows us to set which image we want to show. And finally, a subtitle, which will just uh, say what the image is about. So if you look at the final result in the project, if you go to the skill icon, skill section, you can see the subtitle is JavaScript, React, Next.js, and in the about section, it's here as well. So here we create our icon game object, and by attaching it to the parent by using the add method of the parent, we use the sprite component to display the sprite that is going to be passed, the name of the sprite. And optionally, as the second param, you can specify the width and the height of an image of a sprite. So by having this object, if you by default it displays the image in its natural resolution, true resolution, with sprites, normal sprites, sprite sheets, etc., etc. Don't touch this. Don't add this second param. But for us, in our cases, our skill icons, sometimes they're too big or too small or need to be stretched a bit. So that's why it's nice to be able to tweak the width and height of the sprite. Here I'm using the anchor component, nothing new, to center the game object. To be drawn from the center, the position, and then here it's a new component. It's called the opacity. I initially set it to 0, and then we're going to gradually make it visible. So the opacity component takes a value between 0 and 1. 0 means that the game object is going to be invisible. 1 is going to be fully visible. And then if you look at the portfolio, if you look at the portfolio, you can see that the section gradually appears. And we need to basically tweak the opacity gradually to go from 0 to 1. And the way we have to do that is by first adding the opacity component, and then later on, we're going to be able to tweak it using a tween. I'm going to explain what a tween is when it is relevant. Then here is a component that is very useful for gaining performance. So Kplay is a library that isn't as performant as other alternatives, but version 4000 is working on adding performance improvements. But in the meantime, you can use the off-screen component, which when when the object is off screen, it will hide it by setting the following object as its property. So hide by setting hide to true, and the distance. Here, by default, if you don't put anything, the distance by default is 200, but 300 is a distance that is more appropriate for this project. So what happens is, as soon as it is off camera, it's going to wait until the distance of 300 before making the game object disappear by hiding it. And this will save up performance. And then here I created a child game object of the icon and not the parent, which is going to be the subtitle. And the subtitle will use a text component. We'll use the IBM bold font with size 32 and pass in the text for that. That is passed in the param here. Then here our color, we're gonna pick the color 1 by doing the following. I think I've already explained this. And then here it's a position relative to the icon, as this is relative to the parent and this is relative to the icon, which is relative to the parent. And then finally, I add the opacity component again. And the reason we need to add the opacity component for every game object and not just rely on the fact that the parent already has it is because the opacity does not inherit. So the child game object will not have its opacity value inherit. So that means if you modify the opacity of the parent, it will not change the opacity of the child at all. And this is, I thought it was a bug initially, but in the end, after talking to the developers of Kplay, it's intended because you want to be able, in certain cases, to have the opacity not follow the parent, which is not the case when you want to attach a parent when it comes to positioning, where usually you want If the parent moves, you want the child game object to move with it as well. Otherwise, there is no point to have it as a child. And then finally, I return an array with both the icon game object and the subtitle text game object as well. And this is going to be useful to be able to create our other components. So to be able to differentiate between skill icon and social icon. So we're going to build our skill icon and social icon game objects based on the icon game object. So let's go with the skill icon. And then once we have all of them prepared, we're going to be able to test them out. So for the skill icon, I'm going to do the same thing. You know what? No, this time around, I'm just going to copy the function definition, and then I'm going to type out the rest because there are new concepts I want to cover. So here is our function to create the skill icon. When it comes to the params, it's basically the same thing. Now for the so now we're going to take advantage of the fact that we have the icon already made by importing it. So make icon and calling it. So here we're going to pass the exact same params. So pause vector 2 and even the image data, which we're going to see how in practice it works later on, and the subtitle. And then here I'm going to use, so that's a new concept, is that when you create a game object, you create that game object using the add function or method, depending on if it's a child game object or not. But you also can, after the fact, after creating the game object, add new components. And the way to do that is not using the add function, because the add function is really just for creating new game objects based on an array of components. The way you can add components after the fact is by using the use method on that game object, on any game object. So you can do icon and then the use. And here I'm going to use, and then you can pass a component you want to add. So here k.area is a component. I want to add a hitbox, an area basically, to the icon for the skill section specifically, and you're gonna understand why in an instant. So I'm just gonna show you. So here in the final project, there is a difference between the icons here, which have no collision, no areas, because we don't want to unnecessarily create areas and hitboxes, as it will reduce performance, and it's not needed in this case, in the about section. But for the skill section, we want to be able to play around with the skill icons. And because of that, we need to create a hitbox, an area, and even use the body component later on. So yeah, I think the body component, yeah, we're gonna need the body component as well. So here, if I go back, we have our area. I'm gonna create a rectangle. So using the rect constructor, k.rect. And then, like I explained, the first param is the position relative to the game object. And then the second and third param are the height and width. And here, I'm gonna take the icon width. I'm going to take the icon height, which are properties that are accessible since we created the game object. It's used as a sprite. And here I'm going to have this offsetted a bit because I want the hitbox to cover more than just the icon, but also the text under it. And I don't want to have to create two distinct areas for both the icon and the subtitle text. So here what I'm going to do is use the use method again to this time around add a body component. And then the body component is going to take a, you know what, let's do nothing for now. Let's just add the body component so that it can react to physics. So that's what the purpose of the body component. And now we're going to have an onCollide. I'm going to add an onCollide listener to that. And I'm going to check collisions with the player. And then one thing with the onCollide method is that the second param, the first param of the function you pass is the game object passed as the tag of the game object. Actually, what I want to say is the game object you want to check collisions with will be accessible as the first param of the function that you decide to pass. So to repeat, the first param of the function you decide to pass as a second param to on collide will contain the game object you want to check collisions with the other one. And now here I'm going to use a method called apply impulse, which will allow us to add some force to the game object so that it can be pushed around and slide as if it were on some ice or something like that, which adds to the fun factor of this interaction. And here I'm going to take the player and direction. Remember, the direction was a property we declare on the player game object, and we can have access to it here. And I'm going to scale that by 1000. So that means the impulse is going to be in the same direction the player is going through. And we scale that by 1000 to give to really like a high speed. So now the final thing is we return the icon, but there is one thing, is we need to have a way of controlling the opacity, and the way we're going to do that is by using a tween. But later on I want to come here because it's not enough to modify the opacity of the parent game object. We need to modify the opacity of the child game objects as well. So I'm going to have here to write a to-do where I need to write a opacity modifier for child game objects so that I don't forget. Now let's go to, okay, this is going to be used later on when we do this, because subtitle is a child game object as well. So let's leave that as is for now. Leave it red. Yeah. So now for the social icon, what I'm gonna do is, again, this time around the code is almost the same. So I'm gonna copy and paste it just to go slightly faster. And yeah, I'm gonna paste it starting from here, and then I'm just gonna close the function here. It's not the full code, it's just part of it, but just to show you. So what we have here is, first we need to import the make icon. So I'm just gonna bring also the import statements we need, but this time around we need to hook the social icon with the Jotai store. So the reason we're gonna need this is because we need to be able to open up different links depending on which different links depending on which icon is hit. So there's this link switch that we create. So let me start from scratch and then I'll explain everything. So now we have our import statement for our palette, color palette, the make icon, which are using as the base game object, and then here I just renamed it social icon. I should have probably named this skill icon instead. So let's rename, it doesn't really matter, but just for consistency, I'm going to rename this symbol to skill icon. All right. So now back in social icon, we first create our base icon using the same params. This time around, there's two different data that we pass to the make social icon constructor instead of what we had with just the basic make icon. It's the link and description. So here we also create as a child game object of the social icon a link switch. So the link switch is the circles you see here in the final product, which are going to have an area, and when you collide with it, it's going to open the modal. But what I want to be able to achieve this, when we collide here, Caplay will send that this is the link we want to open to the store, and from the store, the React component is going to be able to read that data and display it in the modal. Hope that was clear. So here again, I can use the circle component to basically display a circle. So that's something you can use in Caplay. And then we have, basically here, nothing is new. new concept, so I'm just gonna go over it basically. And now we have the link switch. We can add an onCollide with it, and we want to check the collision with the player game object. And this is where we're gonna send some data to the store. So I'm gonna import the Jotai store. Where is it? Okay, why did it doesn't suggest me the store? Store dot. Okay, I have to do it manually. Okay, I'm going to go here and import the store from, I think the path was this store. There we go. Then inside this onCollide, I'm gonna do a store.set. This is how you can set in vanilla JavaScript to the Jotai store. So use the set method and then pass in the atom you want to set. So here I'm gonna import the social modal visible atom, and this should be imported on top. And I'm going to set that to true. This is basically sending a data signal that you should open the modal. And then here I'm going to set the selected link atom that we created from the store. Here again, be sure to import it in this file. And then I'm going to pass the link that is from the params we're passing to the social icon constructor. Then I'm going to, well, actually, just to clarify, this isn't a constructor in the sense of object-oriented programming, like in a class, but it essentially acts as one because this is a function that is called make social icon, basically. Just to not confuse you in case you might not be familiar with object-oriented programming and might think that it is a related concept. Now here I'm going to set the description by calling the selected link description atom and then passing in the description as well. And then finally here we're gonna have the same to do. I'm just gonna copy from here opacity modifier for child game objects. And then here just I'm gonna return the social icon. And that's it. So now I'm going to go back to the initgame.js and let's work on our section, our first section, the about section, to display the various things we need. For the first section, the about section, we're going to first create a container that is going to contain all of our icons that we can then move where we want. But before that, maybe we should add the header, like the title, etc. So for example, we could create, you know what, let's create our parent, a container. So const container, which is going to be attached to the parent, and it's going to have a position. This position is going to be minus, I think minus 805 by minus 700. So it's going to be at the top. Remember, the lower the value of y, the higher it is on the screen. I'm going to also use the opacity component to set it at 0 for the same reason I explained, that it is not child game objects, and every game object has its own opacity and they don't inherit from the parent. And now I'm going to add a container, so to the container, sorry. I'm going to add some text. So let's say general text here. And that text will say, you know what, to make things modular, let's create a config file. This config file will contain all the data we need to display in that section, so that when you want to edit the site, you can just go to that JSON file, modify the string, and it will update without you having to code it in. So to do that, I'm going to create a config file in the configs folder we created in the public folder initially. and I'm going to name it general data.json for now. So general data.json is just going to contain an object, and in that object, I'm going to have a header property with the title, which you can place whatever you want. So for example, hey, I'm just legend dev, then subtitle is, you know what, I'm just going to copy and paste that to not make this tutorial longer than it needs to be. So here is a header for the title and the subtitle, and then we're going to have the section names here as well. So feel free to modify this, pause here, and modify it with the sections you want and the data you want here. So now we can go back to the init game, and at the top of the file, even before the Caplay context is created, we can import this data by using a fetch call as if it were an API call, an external API call basically. So how are you going to achieve this? Is just by doing the following. So I'm going to create a constant, call it general data, and I'm going to await once, await twice, and do a fetch, and then here the path is going to be dot slash, and then let me just create some space, dot slash configs slash general data dot JSON, and here I'm just going to do dot JSON here as well. So this is something that you usually see on two statements, two lines, but I just put it in one. So we first fetch the data from that file, and we need to use the await here to get that. And then once we await it, we await until the result is completed, until the file is fetched, etc., before transforming this into a JSON object, which also requires that we use the await. I'm not going to explain async await here in this tutorial. I have done it in previous tutorials. You can find online resources that will go explain this in more details. All right. Now, if I go back here where we created our text component, I'm going to pass to that text component the following. I'm going to get the general data and then do dot header dot title. And then here, you know what? I'm just going to copy and paste the code I had here just to go quickly. So here we create a first game object in the container, which is going to contain the title with the IBM bold font, size 88, which is what looked good, the following colors and positions and opacity. Same thing for the subtitle. Now I'm going to create also another container. So here again, I'm just going to copy it. And this container is going to contain all of our icons, our social icons, switches, etc., so that we can position it. If you want to change the position of the whole thing, you can just modify this once. And then here we're going to also create another config file. So here in the configs, I'm going to create it, no, not here. In here, I'm going to create a new file. And then this new file is going to be called socials data.json. And then here I'm going to, you know what, copy and paste the file I had originally, because anyway, for you, it's going to be different values. So if you are interested in not having to type this out manually, go into this description. You should find the source code of the project, and you can find the appropriate file, and you can just copy and paste it. So here is the shape of it. I'm just going to comment over that. So it's an array. So socials data.json is an array of objects. Each object has a position defined with an x and y coordinate that you set, a name, a description, a link, and then the logo data. And then for the logo data, it's an object with the name property of that logo, of that image, the name here is the name of the sprite you loaded. So here in here, it's this name, the key you decide on initially when you load the thing. And then you set the width and the height here as well. So now let's import that in init game. And we're going to do this here. So like we did originally with the general data, we're going to do the same thing, the same statement, but with the socials data. So here, write the following line. And then we are ready to use that in our code. So the way we're going to do that is create an a for statement, a for loop. So in that for loop, we're going to, for each of them, each of the social icons, so we can do const social data of social data. Oops. Yeah, this. So for each of those elements, if the social data name is equal to email, that's something I forgot to create, is a specific game object. So we had the skill icon, social icon, but there is another one. There is the email icon that we need to create as well. So you know what? For now, let's do create email icon. You know what? Let's do it right now instead of postponing this. So create a file in the components folder. Sorry. Call it email icon.js. And then once you have this done, I'm going to just copy. So I'm going to just copy the same thing, have a return statement with the email icon, and you have the to-do we need to do here. I'm not going to specify because it's the same thing. So now here, let me explain what is happening. So this is an utils function we're going to write later on, so ignore that for now. Okay, so what do we have here is we have the following things imported: the email atom, because we need to set the email. We need to send to the store the email we want to display. Here you could have hard-coded this in the sense that, you just go into the store.js file and just write out your email. But here I thought I would do it in the same way as the skills icon. So what happens is we create the email icon, email switch in the same way, but this time around what changes is the onCollide, which instead of doing what it did in the skills icon or the socials icon, it will just set the is email modal visible atom to true, and then set that email, which is the email passed to it from the JSON file. And if you notice here, there's in the socials data.json, I think I've put the email here. So this is a different property, address, compared to the others, which do not have the address, but the email one does not have the description. So that's that. Okay, so we have created this, and now we're ready to go back to init game. And in init game, I'm going to, if the social data.name is the email, we can just create, so I'm going to call the email icon. So make email icon, pass the context, pass the social container. Then for the position, this is where we're going to pull the data from the file. So for this social data, we're going to do pause. And then actually, because the data structure accepted is not the same as in the JSON, so you have to create a vector 2, pass in the social data.pause.x, social data.pause.y, and then the image data is going to be the social data.image data, and the subtitle is going to be social data.subtitle, and then the email, in that case, going to be social data dot email. And if I look at the result, you can see this. And then we can continue forward. And then if it's not the case, then we're just going to make the social icon the same way. So here, K, and then pass in the social container. And then here the position. So I'm just going to copy this as well, like that. And I think the difference is just that there is a description now. Social data dot description. Actually, I don't remember the order. Let me just look it up. So here we have image data, subtitle, and then link and descriptions. Here, subtitle. Actually, we need the image data. Social data dot subtitle. And then after subtitle, it's link. And then finally, social data dot description. Here we go. Now I think we're ready to test this out. Let me just make sure that we have the correct order. All right. So let's look at the result. So if I go here and here is our game. If I go to the about section, there is a bug. All right. Image data is undefined. Play.js. Okay, inline. Icon.js. Line 5. Okay. So init. Social data, image data. If I look at the socials data, okay, it's called logo data. Okay, like instead of image data. But in the function I created here, it's image data. So I should have, I should have been consistent. Sorry. So here, instead of image data, you need to pass in logo data because that's the name of the property. But you know what? No, I'm not going to change my code here. I'm going to go instead to the socials data. I'm going to rename this symbol. Change all occurrences to image data. Here we go. Now things should work without modifying my code. Without having to modify my code. So now let's open that up and then nothing is happening. Strange. Why is that? Ah, okay, I know why. Because the opacity is 0. It's invisible because of that. But if you see like with the debug mode, you can clearly see that the hitboxes are here. So let's next, what we're going to do next is write the opacity code, the code that handles the opacity. And then once we have that, we can start working on the other sections. So now let's write two utility functions that are going to take care of dealing with opacity. So I'm going to write these two in the utils.js file. And the way I'm going to do that is the following. So I'm going to export an async function called make appear, and it's going to take the context and what you want to make appear, which game object. So the second param is going to be the game objects. So game obj works as a good name. Now I'm going to call the tween. So it's time to explain what a tween is. So a tween, I think I did it. Maybe I did not do it in this tutorial. So a tween allows you to change the value of a variable or something gradually over a period of time to arrive at a target value following a certain rate defined by an easing function. So what we're going to do here is first get the opacity, the current opacity of the game object as the first param, which is the starting value. The target value is 1, so by default things are invisible, so the opacity is 0. Then we want for it to go to 1 in 0.5 seconds. And we're going to create our function that takes care of gradually changing the rate, the opacity. So I'm going to do game object dot opacity, and then set up with the new value here. Then I need to do this for all game objects as well, child game objects. So I'm going to do const child of game object dot children. This is a property that is accessible for you to be able to access the child of the game object, but it can only allow you to access the current child, the direct children of your game object. So here I'm making sure the parent opacity is going to be the same for the child opacity. So I'm setting the child opacity through the parent here. But as I said, there's an issue, is that you have to do some other, we're going to have to write a second function to change the opacity for children game objects that are indirect. So a child of a child game object. So now for the tween, the last param is the easing function. You can access it by doing k.easings and then picking whichever you'd like. So here linear is the one I like to use. So now for child game objects that are indirect children, I'm going to add the following function. So what it does, it's called opacity trickle down. It will trickle down the opacity from the parent to its indirect children. So here I create this opacity trickle down property inside of the parent, and then I attach to it this onUpdate loop, which will then get the indirect children that we pass to the to this function, which will set up the indirect children opacity to being the same as the parent opacity. And we're set. All right, so now let's try using those functions. So in init game, I'm going to copy and paste them. So here, right after that, I'm going to have them here. And now I should also import. So first we call make appear. And then later on, we're going to add where the to-do is here in all of the icons. We're going to add the second function that we wrote here. So now up above, I'm going to import it. So import make appear from utils. And now we have attached this make appear function to make the container and the social container containing so the container contains the title and subtitle, and the social container contains the icons. And it will make sure to change the opacity from 0 to 1. So let's test that out. So here, if I go here, the section appears, but not the icons, the switch. And there's an issue as well due to the collision handling. Let me test that out again. So if we do something like that, yeah, there's still code we need to write in the player logic for it to show the model and prevent the player from moving, but mostly prevent the player from moving, and then we show the model. Anyway, so that's the next step. To fix the issue we had, which was that the icons here don't appear, and when we hit them, the modal doesn't appear. We need to first go to the React UI.jsx file and add all of our components that we created, our various modals, to it so that they are accessible. So here I'm going to add the social modal. Well, I don't remember the, yeah, social modal. Social model. Do it this way. Maybe it will tell me to import. Nah, never mind. So in that case, I'm just going to import it manually. Social model. Okay, why does it not work? My import statement. just making sure that okay, it's exported. So it should be social modal from component React components and then social model. And then we're going to do the same for the others. So for the email model, same logic. And for the project model. And then here I will have to manually write my import statements. So import email model from, not form, from React components slash email model. And then finally import project model from React components slash project model. All right, so now if we test things out, you can see that there's an issue. So first, let's have this. And then we have our modal that is down there, which is not what we want. I think this is a CSS issue. So let's fix that. Okay, so for here, we're gonna need to add top 0 to have 0 for that the modal will be positioned correctly like that. So now it works. So what I wanted to do is by adding top 0, we're making sure that when I opened up, this is supposed to appear in the correct place. All right, works. So yeah, that was one thing I didn't add. So having the top position being 0. So the offset from the top. All right, now that we have this, we have our working model. I think, yeah. Yeah, so we have our working model. In the end, we don't need to modify anything, I think, regarding the player logic because everything works fine. So now the only thing left is the fact that the circles, the switch, are not visible because they are indirect children of the container. So as I said, to fix this, we need to go to each of those icon, skill icon, and here, instead of having the opacity modifier, this to do, I'm going to remove that, and we're going to call the opacity trickle down function that we wrote in utils, pass the parent here. So here the parent is, okay, it's passed here in the params. And then for the game objects that are indirect children, we're going to pass. So here we're in the skill icons. So the subtitle text will be passed here. So when a child game object is a direct descendant of that game object, we don't need to run this function. However, if it's not the case, we need to do that to also set the opacity to being 0. To being 1, sorry, to being the same as the ultimate grandparent, I would say. So now if I go here, so this is for the skill icon, sorry, for the skill icon, we didn't write the logic for that. So we're going to take this exact same thing, and we're going to go into social icon, and here we're going to pass both the subtitle text and the link switch. Game objects, import opacity trickle down from utils. And then we're going to do the same for the email icon. Gonna copy and paste that, and it's going to be subtitle text and the email switch as well. And then of course you need to import the correct tail function, so opacity trickle down. Okay, so now that we have that, things should be working. We haven't worked yet. There is the project card later on, which is the other game object that we're going to work on, and the experience cards, which is also going to be something we're going to work on next. But for now, let's look at the result. If I go here, you can see the undefined, 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 undefined. Okay, this is wrong. Why it's undefined, we need to figure this out. So in init game, here, when making the components, the subtitle, is it at the right order? So after image data, we have the subtitle. If I look at the file, socialsdata.json, the name, okay, it should be, okay, so that it's not subtitle. The property is called name. Name of the, and then here as well. So here as well. So it's the name of in the socialsdata.json, but in our constructor like function that makes the social icon, we call this a subtitle. So I'm going to keep it this way. So now if I open up, go back, and you can see the various social media websites. And then here for the email, copy my email to your clipboard. If you click yes, it will copy the clipboard. Let's test out if it opens up the link. So if I click yes, it opens up my Substack. By the way, I recommend that you subscribe to it. And then same thing here with YouTube, GitHub. So for example, for GitHub, if I click yes, it should open my GitHub. All right. Now it's time to work on displaying the skills section next. All right, for the skills section, we're going to work using the same logic. So I'm going to go here. One thing I want to add here is before moving on to the skills section, for the about section, we can pull this up from the general data. So general data dot section, what was the name? I don't remember. So in the configs, general data.json, section 1 name. We can do that here. Let me find the file. Section 1 name. And now if I look at the result, it still works. All right. Okay, for now, let's tackle the second one, the skills section. And then here I'm just going to replace it from the get-go with the general data.section 2 name. I think that's the correct name. Let me look it up. Yeah, okay, it didn't change. So here, the same logic will apply. We will create our container, which will contain the various icons. So here, I'm going to create a const container and k.add, and then opacity of 0 and a position of parent.position. So here I'm creating the container independent from the parent. Here, did I do the same? Okay, so this is a mistake on my part. I created the game object in my original source code, not relative. The container is not relative, is not a child of the parent game object. So that's a oversight on my part. But I don't want to like tweak values, etc. I just want to have the exact same values. So maybe, you know what? Let's fix this. In the original source code, I didn't do that, but here I'm gonna add it as a parent, as a child of the parent, and it's going to be the position. Instead of having parent pos.x minus 300, it's going to be minus 300 immediately, because remember, a child game object is placed relative to the parent. And then here it's going to be 0. So now that we have our container, it's time to create our next config file. So here in our configs, let's create a new file. This file is going to be called skills data.json. And in there, I'm just going to copy and paste what I had. Here we go. We have an array of objects, and each of objects has a position, a name, a logo, data, and that's it. And the logo name here is the name of the sprite loaded using the load sprite functions in that game. So let's import that file immediately. Much the same way, we just go do this, copy, and then paste it right below, and then change the name here to skills, not kills, skills data. And then here, instead of social data, it's skills data.json. All right, and now we go back here to in the game. I'm going to, not in the project section, here. I'm going to create a for loop for const skill data of skills data. And then here, I'm going to call my make skill icon constructor. It should be imported. Pass in the K, pass in the container, which is the parent in this case. And then for the position, it's going to be skill data, not data, data. Dot pause, dot x, and then skill data dot pause dot y, and that's it. And then here I'm going to have the skill data dot logo data, which will contain the data we need for the image, etc. And then finally skill data dot name. All right. All these info comes from the skills data JSON file. So now I need one last thing, is called the make appear function. Okay, and then pass in the container. And because in this case we don't have, actually we do have the trickle down thing for the skills icon, so just having this is enough for the container and each individual skill icon, but not for the subtitle. But we already fixed that case, because if I go to the definition, we added the opacity trickle down to change the subtitle text as well to be the same as the parent, which is the container in this case. All right, so now let's look at the result. And if I go here, you can see the skill icons appearing, and now I can even push them around, and that adds a lot of fun to the project, to someone visiting who wants to play around a bit. All right, so now it's time for the other two sections, the experience and project sections. For these two, we're going to, for the experience section, we're going to need to create an experience card and then display your experience. But for the project card, we're going to need to also create something to display each project in their thumbnails, and then display the modal, etc. So that's what comes next. And after these two portions of the project are done, we're pretty much done with the project, and it would be the end of the tutorial. So now let's work on the experience card component that we're going to add to the experience section. So in the components, let's create a new file called wait a minute. Yep, here. Project or work experience cards. So this is for the work experience section. Sorry. So work experience card. Here again, it's the same logic as always. I create a function, constructor function, and then yeah. So for this, I'm just gonna copy and paste the code and explain over it any new concepts. So here it is. I'm gonna go over it. So we have our import statements. Nothing new here. The make world or make work experience card, and then for each we have for the param, sorry, we have for that is the context, the parent, the position, the height. The reason we have a height here is the height of the card. which you can tweak depending on how much text you want to display to describe your work experience, and then the role data, which contains data related to the job title, the tenure, and basically the start and end dates of your jobs, and then the description. So here we first create a card game object, which is a child of the parent, using the rectangle with a radius. So this as an optional third param. You can pass in your radius, which will round the corners a bit. You can use the outline component to have an outline alongside the rectangle, which is pretty handy. And then the first param is the thickness. The second optional param is the color you want to use for the outline. Then the positional vector, and then the color of the card, the rectangle itself, not the outline, is set here. The opacity 0, and as I said, off screen here we use to gain on performance. Then here for the title card, it's going to be a child of the card, so it's within the card, the title. And then we use a text component to display the role title with an IBM bold font, size 32, with the following color, with the following position relative to the card, and the following opacity. And then we have the history card. I don't think I used that though. Never mind. So I made the mistake. So this is not necessary. Here is the history of your job. So you put the company role data, the company name, and then the start date and end date here. And then a smaller font, and then the following color and position and opacity. Same thing for the description. Here again we use the opacity trickle down, which is which for changing the opacity of indirect children of the parent, which in this case is the title, history, and description, which are all children of the card, which is a children of the parent. So that's why it's indirect, and we need to use that. All right, so now that we have this, we can return the card. Now, if we go to the configs, let's create our config file for the experience. So I'm going to call it experiences data.json. Here again, I'm just going to copy the file. So this is the data. So a array of object with the position, card height, the role data, which contains the title, the description. This is important when you want to use brackets like that. You need to escape it, otherwise Gaplay will throw an error. So you need title, description, company, and a name, start date, and end date. So that's the shape of the data I've decided to use. So now finally we can go to the initgame.js, and then here in the section for, well, first we need to import our data. So in this case, right below, I'm going to copy this. And then here I'm going to do a experiences data. And then you here have the same name, experiences data. So now finally we can go to the third section, which is the experience section. So after this one, I'm going to replace this with the general data section 3 name. And then here we can work on adding this to our, so the way I did it for this section, I don't remember quite. Okay, let me just look it up. Okay, so we first create a container as always. So a container as a child of this, and then the opacity is 0. As for the position, in this case, it's also going to be 0. So there's not much need, except that it's nice to be able to move all the experience card at the same time rather than individually. So that's why they're grouped as a container, in the container, as child of the container. And then I will have a for loop, const experience data of experiences data, which we pulled from the JSON file. And then we're going to call the make work experience card function, pass in the k, pass in the container, which is the parent, pass in the position, so k vector 2. And then in this case, it's experience data.pos.x, experience data.pos.y, and then experience data, we need to pass the height. And then after that, we will have the experience data role data that we pass as well. And that's it. And then finally, we of course call make appear on the container. So first we pass the context and then the container, so they gradually appear. Go from 0 opacity to 1. If I look at the result now, I do this, and it's a big error. Why is that? It's okay. It requires property width and height from rect, etc. Did I mess something up? Work experience card, position, vect height, experience data. Okay, it's called card height in the original file, in the JSON file. That's why. So in the JSON file, experience data, I called this card height. That's why. Now if I look at the result and I go, you can see the card appearing with the experience. And that's it. That's this section is done. So the last section is for the projects. Sorry. So let's work on that next. All right. So for the last section, I'm gonna immediately create the necessary config file for the project section. So it's going to be called projects data.json. As for its content, it's going to be the following. So here, depending on your project, of course, so feel free to modify this section to reflect your own projects. And then for the components, the game object components, I'm going to create a file, call it project card.js. And here it's going to just build the card we need. Here again, like always, I'm just going to copy and paste the code because at this point there is no new concepts. So here we have our function, the following params, and then we create a card, and then a card mask. Okay, so this is a new concept. So in the final project, our cards, our thumbnails for each of our projects have rounded corners, but they are images. So the way you achieve this is you create a mask, which is a rectangle with a radius of 10, which is going to be a rounded rectangle. And then by using the mask component intersect, it's going to, when you use the, you add to the mask, the game object that uses the mask component, another game object, here the sprite, is going to follow suit and also have rounded corners. Because by default, the thumbnails are rectangulars, rectangular like images. They don't have rounded corners. So this is how you achieve it, by having a mask on top and then setting the param here for the mask component to intersect for the mask, and then adding the sprite as a child game object of the card mask. So that's something new. Here is the thumbnail with the hard-coded width and height, which looked good. Feel free to experiment. And then we have the card title, which again just takes the title, etc., and position it accordingly. All of this you can copy. So I recommend that you go to the source code and just copy it from there. But if you want to copy right now, feel free to pause here and here and here as well. And here you see we are using the store to set is project modal visible true, and then sending the appropriate data to the chosen project data atom so that we can have the correct links sent. That's why if you go to the project's data, you can see the data is the title and then an array of links for the links property with an ID, name, etc. And then, of course, the opacity trickle down for the card mask, the image, the card title, and the card switch, because they are all indirect children of the parent game object. And that's it. Now, it's time to go back to init.game.js. Then here, I'm just going to copy that. And I'm going to call it, just modify the names, of course, projects data. And then here the file is projects data as well. And then finally we can go down to the last section. Here I'm going to use the general data section for name. And then here we can create our container. I think we are also going to have a container, much like all the other sections that came before. So here I'm just going to, no, I'm not going to copy and paste. I'm going to write it out. So container parent add k.opacity, and then for the position k.pause, we're going to use 0. Here we go. And then finally, we're going to have a for loop, which is going to const project of projects data. And here we can call the make project card, pass in the relevant data. And then finally make appear container. Now let's look at the result. If I go here, and you can see live demo, source code, and then closing. So that's it. That's the project. The full project is now done. And yep, so hope you enjoyed this tutorial and you learned a lot of things. As always, the source code is in the description if you want to compare with your version. If you enjoyed this tutorial, feel free to subscribe so that I can know that you want more like this. And feel free to also look out at my other videos and tutorials. Thanks for watching, and bye.